Hello, welcome to Working with Time. I'm Jessica with SPLUNK Education. Time is one of the most important components to consider when working with your data. In this module, we will learn how to work with time in searches, including time-based functions and commands, and understand how time zones are represented in your data. To know how to create searches including time, it's important to understand what time means to Splunk. When an event is ingested, its timestamp is stored in the time field. This is used to create the event timeline in the Splunk web user interface. The time field is stored with the event in the index prior to search time, along with default fields such as host, source, and source type. Timestamps are expressed in Unix or epoch time and translated to human-readable time during the search operation process. All events are sorted by time, thus, time is the most efficient filter. The _time field's timestamp is displayed underneath this time column within each event. That timestamp is adjusted to your local time zone as long as the time zone is set within the account settings. Along with that, every single event will have a specified host, source, and source type, as well as the index that event is stored in. What we'll see when we run a search above the events is a timeline, which is an overall distribution of the events in relation to the specific time range set for that search. This timeline is interactive. We can zoom in, zoom out to a specific time range within the timeline. We can format it to give it a full-blown X and Y axis. And we can start rearranging our time range depending on how we interact with this timeline. We'll notice that if we click and drag a portion of the timeline, it will be a subset of time, in this case, 6 hours. And if we would like to update our time range to zoom into these 6 hours of data, we can select Zoom to Selection. The event list updates when we click and drag over one or more bars within the timeline and displays only the events that occurred within that selected time range, being a filter of the search results. However, the search will not rerun. It is essentially just filtering the events and displaying them as usual in reverse chronological order. If we wanted to cancel this selection, we can select deselect, or Zoom to Selection will allow us to filter the results of our previous search for our selected time period and update to show the results of the new search. In that case, we've now zoomed into the selected time range, running a brand new search. Let's go ahead and switch on over into a demo and run a search here, specifying our security index, source type of Linux Secure, and we are looking for failed logins into the server across the last 24 hours. Now we'll notice here we have a couple small peaks within this time range. Notice that if I hover over the timeline, I can see the time range is set to 1 day, which is correct in terms of what my time range is set to, which is the last 24 hours. And I may be interested in some cases if there's a gap in my timeline or a sudden peak in my timeline, what occurred within that specific time range within my events. So the option for zooming on into that section is just clicking and dragging, and we'll notice that as I continue dragging, I can see the time range expanding. These are 4 hours of time between these specific hours of May 13th, and I can see that I'm filtering to those specific 4 hours, but if I wanted to zoom to selection, I'm rerunning a search, zooming in and looking at the results of that search. And I can see that now, since I'm looking at 4 hours worth of data, this is going to update my timeline for this brand new search. Now, zooming out does not take me back to the previous timeline. It literally zooms out in time. If I wanted to go back to my previous timeline, I would just go back within my browser and possibly, let's say, zoom out, which would further expand this from 1 day to, we'll see here, 1 month. And as we continue expanding and zooming out in time, the time range continues growing. Now we can control the overall time range for our search with a bit more detail using the time range picker. The time range picker has quite a few time range options to choose from. One of those being the preset section with a set of time options to choose from, let's say last 7 days, last 24 hours being the default, previous week, previous month, or we can run a real-time search. The real-time search will return results up to the second they're coming in. Benefit of that is that we see data as it's coming in to Splunk in real time. Downside is that real-time searches are resource intensive. Real-time searches will consume an entire CPU core. They continuously update search results as the events arrive. However, if we're running multiple real-time searches, that could possibly impact the overall performance. One alternative to consider would be to use something like a scheduled report. Now, along with these preset time ranges, we can also see that we have some relative time options where we can specify our earliest time range a few seconds ago, minutes ago, hours, days, weeks, months, quarters, or years. Latest will be up until now or the beginning of, let's say, the current hour. The specific date and time will be displayed right underneath. And there is an entire dedicated section to real time, where we can provide the units for how earliest and latest will be up until now. What this will do is it will essentially display the data that has come in, let's say 1 hour ago, up until now, as it's flowing into Splunk. Now, along with that, we can also be a little more specific in terms of our dates. If we'd like to search for data that came in, let's say, between last Tuesday and Thursday, we have an option to specify a time range between that, along with the date and time, let's say last Tuesday and Thursday at noon. Those events with those timestamps will be returned. And then lastly, we have the option to specify time unit abbreviations within this advanced section, which will allow us to be even more specific about our time. With these time unit options, we can use them within the earliest and latest time modifiers in our search or within that advanced section of the time range picker. The syntax is we use plus or minus to look forward or back in time. The specific time unit, and we can round down or snap down to a specific time unit using this @ symbol. Let's take a look at a couple examples. If we are interested in running a search and returning results that have come in across the last 30 minutes, snapping down to the beginning of the hour, in that case, that will, let's say, look back at 9 o'clock if it's, let's say, 9:30, and snap down to the beginning of the hour, which in that case is going to set everything to the right of the hour to 0. We are rounding down to that time unit specified after the @ symbol. Now, along with that, we can use -H at H to round down to the hour. And we can also look back a month ago, rounding to the beginning of the month, last 7 days, or looking for events, let's say from 3 o'clock to 9:45. This is all dependent on what your current time range is set to. All of these searches assume that the current time is exactly 9:45 a.m. on April 1st, 2021. So with these time unit abbreviations, we have the option to specify the current date and time, seconds, minutes, H for hours, D for days, W for week, days of the week, months, quarters, along with years. And if we take a look here, we'll notice that this advanced section of the time range picker allows us to incorporate these time unit abbreviations. We are looking back 24 hours ago, snapping down to the hour, and we'll notice that if I remove that @ symbol, 24 hours ago from now is going to be 11:04 p.m. and 55 seconds. However, I decided to snap to the beginning of that hour, which will round down to the hour, which will be just 11 p.m. up until now, which is the current time. That's applied and that's updated as the time range for this search. However, with the earliest and latest time modifiers, I can update this to say, let's look back across the last 5 minutes of data. I'm including earliest here equal to -5 M for minutes, snapping to the beginning of that minute, and latest is now. Now, which time range will take precedence? The time range that I have embedded in my search or the time range in my time range picker? Notice right below here, the time range embedded in my search using the earliest and latest time modifiers is what is used for the time range. That will take precedence over whatever time range is set in that time range picker. There are a set of fields that are available in most cases for controlling the time of our searches. These fields all begin with a date underscore prefix followed by a specific time unit, whether that's hour, minute, month, second, year. They follow the same format, and these date underscore fields are only generated for events where inside the raw event, Splunk is able to extract the timestamp. Now you may be wondering, don't all events that Splunk logs have timestamps assigned to them? Well, every single event will be assigned a value for underscore time, but not all source events have an actual timestamp value in them. Let's go ahead and take a look at an example here. Running a search across index equal to web, source type equal to access combined across the last 24 hours. If we take a look at these events, we can see that there are indeed timestamps in the raw event, wrapped here in square brackets. And we can see here that we have an IP address preceding it, right? But there's a timestamp right after that. In a lot of your log files, the first value will be a timestamp. And Splunk's default event processing is that it wants to break events at the timestamp. Whenever it sees another timestamp, it will want to break it into a new event. Now, are the timestamps in this time column and within the event itself always going to be the same? In this example here, we can see that the time is the same. We're looking at 6:38 and 27 seconds p.m. And we're seeing the same thing in the timestamp in the raw data. Now, the reason that these are coming up the same right now is because if I make my way up into my account settings and my preferences, what I'll see here is that my time zone is set to the default system time zone. I am using the time zone of default system time zone, so there is no localized offset being applied to my underscore time field. If I were to change this to my local time zone, what would happen is there would be a differential from GMT, so the timestamp value would be offset from the underscore time. In that case, if I apply this, rerun this search, and we see differences between what appears in the raw data and in the time column, notice there's a difference there. Chances are we've set a local time zone preference. Now let's take a look at a different set of data. We'll change our index to OS, source type to PS. PS is a scripted input. It is a process snapshot Unix command running in the background every 30 seconds. We captured the standard output into events, and we'll notice that we don't have any of those date underscore time fields in the sidebar. Versus for the previous search, if we take a look at the field sidebar, we have all of these date underscore prefix fields available. Now, the reason why we don't have any of those fields is taking a look at the actual events themselves. There is no timestamp. Splunk is not able to extract a timestamp from within the event, yet a timestamp is applied for those events. So the question is, where did this timestamp in the time column come from? Notice that the timestamp is the same for each event. Splunk tried to find the timestamp inside the event. It wasn't able to, so it defaulted to its fallback, which is the index time. That is the time that these events were indexed, and that's what gets assigned for underscore time. There are no date underscore fields present here, and that's because Splunk was not able to extract them from the event itself. When they're present, we can use them to solve specific use cases by using them in our searches. If we take a look at this scenario here, let's say a new campaign aimed at early morning sales is ongoing, and we want to display early morning retail sales for 2 to 5 a.m. for the previous 2 days. All right, so let's go ahead and run a new search here, and we are going to look at the time range for the previous 2 days across the index of sales, source type of vendor sales. Earliest is looking back 2 days ago to the beginning of the day. Latest is snapping down to the beginning of the current day. Looking back 2 days ago will be on May 12th. To today, May 14th, snapping down to the beginning of the day, which is midnight. And we are interested in displaying early morning retail sales for 2 to 5 a.m. for these previous 2 days. Notice in the field sidebar, we have the date underscore hour fields. Let's use those in our search and specify date underscore hour greater than or equal to 2 and date underscore hour less than 5, which will work with the midnight time looking forward 2 hours. So we're looking for a value greater than 2 and less than 5 to look at the retail sales between 2 to 5 a.m. for the previous 2 days. If we run this search, what we're going to do from here is place our data in a table. And what we will use is this command called the bin command, where we are going to bin up the time values, each being 1 hour apart. And what we'll then do is place this information on a table looking at the total revenue, naming this hourly sales by underscore time. And what we should see on this table is early morning retail sales from 2 to 5 a.m. Now, if we reformat this underscore time value to make it a little more readable, we can use a function of the eval command, create a new field called hour, and the function here is called the strf time function. The first argument will be the field that contains the time values, in this case _time. Second argument will be the date time format variables in the format that we want to place them. So in this case here, we will be using %b, %d, %i, %p, which is going to display this in month, day of the month, hour, and whether it is AM or PM. We can find these date time format variables and their descriptions in the Splunk documentation on the strf time function. Let's go ahead and run this search and take a look at this newly created field and its values in this column. And we notice something that isn't as we expect. We expect this to be 2 to 5 a.m., not 7 to 9 p.m. So why are we seeing a difference in the actual times? Well, remember, we changed our time zone earlier. So if we make our way back up into the preferences, switch back from Pacific time to the default system time zone, apply and rerun the search, we will notice that those time zones are updated and the time values are correct in that hour column. And we can then just place hour and hourly sales as the two columns that we want in our table. The date _ prefix fields do not account for time zone. Now, in that last search, we just used the bin command. The bin command is used to help us bucket up our events. We can put numerical values into discrete sets or bins, and the bin command has a span option that is set to an integer or a timescale that allows us to set the size for each bin. In this case here, we can adjust the bins if they're being organized based on time using the span option, specifying a time interval where these are each going to be 1 hour apart. And here we have an example of the different timescale values that are available. We can specify seconds, minutes, hours, days, months, subseconds. And one example here is that we would like to list the number of times an action was seen on the SIEM Cubicle beta server over the last 10 minutes and group actions into 2-minute chunks. In this case, we're searching across our games index source type of SIMQ beta, looking for events that contain an action field across the last 10 minutes. We are going to group together the _time values, each of those time bins being 2 minutes apart, and then placing that information on a table, getting a count of events and listing out the actions by time. Now, along with binning up _time, let's take a look at one more example using the bin command, this time going back into our online transactions and displaying the total revenue per product across the last 24 hours. We will pipe to the stats command, sum the price, name this revenue per product, and run this search. I would like to bin my revenue by piping to the bin command, passing in revenue as the field and running the search. And what I'll notice here is that these different values are grouped together and these bins are each 10,000 values in terms of what the span is set as. If I wanted to adjust the span, I can specify span equal to, let's say, 5,000. So I'm lowering the span count, each of these bins now being 5,000 values in terms of the overall range. Now, if we wanted to look at the list of products by revenue and see all of the products that fell within each revenue range, we could go ahead and pipe over to the stats command, list function, product name, by total sales, and display this information in a table. Now, total sales is not a field that we're working with, so we want to make sure that we're specifying the correct field. In this case, it is revenue. And so what we're looking at here is all of the products that fell within the $0 to $5,000 range, $10,000 to $15,000 range, $15,000 to $20,000 range, $25,000 to $30,000, and $5,000 to $10,000 range. If we wanted to, let's say, format these numeric values to display monetary values, we can update revenue and concatenate a $sign to the front of these values here, that then being updated. You can define how time is formatted in the search results by using the time functions of the eval command. The eval command is a very powerful command that allows us to write the results of an expression to a new or pre-existing field. We can chain multiple eval expressions together by comma separating them, and the eval command supports its own set of functions. Some of those functions being date and time functions that allow us to generate time values and manipulate time. If we take a look at the now function returns the time that a search was started. The time function returns the time that an event was processed by the eval command. We can set those functions as values of the fields that we're creating with the eval command that will store those particular timestamps. The relative time function is a function that takes in two arguments, the first argument being the actual time value. That time value will be represented in epoch time, and the second argument being a specific time specifier using the time unit abbreviations. S for seconds, M for minutes, H for hours, D for days, W for weeks, MON for months, and Y for year. If we take a look at this example here, we're creating a new field called yesterday, setting it equal to the relative time function. First argument will be the time generated by the now function. Second argument will be based on the time right now, we are going to look back 1 day ago, snapping to the beginning of the current hour. What this is going to result in is a time value, which is represented in epoch time, stored as a value for that field of yesterday. Now, for working with the strf time and strp time functions of the eval command, these have date time unit abbreviations, each one representing a different unit of time. If we take a look at an example here and make our way over into the SPLUNK documentation, date and time format variables page, we can see some information about what each one of these mean when we're using them in these functions. And what we'll notice here is if we're interested in specifying AM or PM, percent lowercase p, if we're interested in specifying the full weekday, percent uppercase A, abbreviated weekday, specifying months, years. So here we have a few examples where if we place symbols, those symbols will actually be displayed in our result. This is helpful for formatting our time values, where in this example here, the epoch time generated by this relative time function, which is stored in the yesterday field, is going to be formatted into a more readable format by this strf time function, where the time value that's stored in yesterday will be passed in as the first argument, second argument being in the format of year, month, day, hour, and minute. So jumping on over into an example here, Let's go ahead and run a new search using this strict time function where we are formatting the time values. If we take a look at our retail sales data, index equal to sales, source type equal to vendor sales, and we display our data in a time chart where we're interested in looking at the hourly sales. And we would like these time buckets to each be 1 hour apart. We can see the underscore time column contains these time values displayed in the month, day, year, hour, minute format, but I would like to format this into something a little more readable using the strict time function. So what I will do is pipe to the eval command, update underscore time. As an alternative, I could create a new field just to compare it to underscore time. So we can create a new field named, let's say, formatted time, and set that equal to the strict time function with underscore time as the first argument. And then we're going to use these date time format variables, percent lowercase b being the abbreviated month, percent lowercase d being the day of the month, percent uppercase I being the hour, and percent lowercase p being AM or PM. We run this search, and we can see that formatted time being displayed here in this column. Now, difference between the strict time and the strp time function is that this function here is going to take a time represented by a string to a Unix timestamp. So we're essentially going from a formatted value to epoch time. First argument will be the field that contains those formatted time values. Second argument using the date time format variables in the order that the format is specified in for that first argument. This will result in a newly created field with those epoch time values. If you've ever worked with time-based data for multiple geographic locations, you know time zones can be tricky. In this segment, we'll learn how time zones are represented in your data and use the strict time function to correct time zones in search results. One thing to keep in mind is to always check your data to verify that it is returning the expected results. What we see here as the results of this search that contains a bin command as well as the date underscore hour fields displaying the early morning retail sales for 2 to 5 a.m. across the previous 2 days. We can see here that we are displaying 9 to 11 p.m., whereas we're expecting 2 to 5 a.m. Now, one thing to keep in mind is your time zone. Remember that the date underscore time fields do not take into account time zone of Splunk Web. All right. So in this case, we want to make sure that we are setting our time zone to the default system time, or as an alternative, using the strict time function to organize our data and normalize it. The strict time function, we can pass in the underscore time field as its first argument. Second argument will be the specific hour. And the difference here between the date underscore hour and my hour is taking into account the time zone that is set. Using the eval command with the strict time function uses the timestamp that is aligned with your time zone to retrieve the hour from the event and return a human readable format. The date underscore hour field will not adjust the hour based on your Splunk Web time zone. So rearranging the search from earlier with the strict time function as opposed to using the date underscore hour fields, if you'd like to use your set time zone, we can create a new field called my hour equal to the strict time function where we are formatting underscore time to be displayed with that preserved time zone.
Hello, welcome to Statistical Processing. My name is Jeff and I'm with Splunk Education. In this module, we'll learn about commands and functions that can help you transform, manipulate, and format your data. Before we get started though, what exactly is a data series? A data series is a sequence of related data points that are plotted in a visualization. In this module, we'll cover three types of data series: single series, multi-series, and time series. Single series data is a sequence of related data points that compares values of a single data category. Multi-series data is a sequence of related data points that compares values of two or more data categories. And time series data is a sequence of related data points that compares values over time, which can be either single or multi-series. Transforming commands can be used in searches to organize your results into a statistical table containing a data series that can be visualized. In this module, we'll learn how some commonly used transforming commands are used and how to structure your searches to generate the results you need for the visualizations you want. The chart command is used to take results and return them formatted into a table. Here, we can see an example of the chart command, which will return results in a table format that can be displayed as a visualization. The pipe chart section calls the command. It is then followed by the particular statistical function we are interested in using. For example, count or sum. WC field in this example would be a field that contains numeric values. We can then specify the x-axis of our visualization and also the first column in our resulting table with the over clause, followed by the field we wish to split our rows by. Splits of our columns, resulting in multi-series data series, is accomplished by using the by clause. We also have the option to control our results further with the span, limit, use other, and use null arguments. Splitting our results based on the values in a set of fields is accomplished with the over and by clauses. We can create a single series split with the over clause and a multi-series split by adding a by clause. Unlike the stats command, the chart command can only be split over two fields or dimensions. A chart command with two arguments after the by clause is equivalent to using an over and by clause. These are functionally identical. Here we can see that our initial search produced a number of results. We can then choose to count these results with the chart count section of the search. We can then choose to split that count based on how many events contain a given value in a particular field. In this case, let's split our data by the vendor country field. This result can either be displayed as a table on the Statistics tab or in a graphical representation on the Visualization tab. Let's now show an example of a multi-series split, one that incorporates both the over and the by clauses. In this example, we can see that we have kept our x-axis and the first column in our chart as the vendor country field. However, let's now add an additional split using the by clause. With the by clause, we can further split our count by the values found in the product name field. This results in a split of our initial count into separate columns in our statistical table. This is also reflected in our visualization as well. We can see here in the resulting visualization that we are keeping vendor country as our x-axis, but now the counts for Canada and the United States are further split by the count of each product. The values for our second split are represented by individually colored columns, and a legend for these values can be seen on the right of the visualization table by default. By default, Splunk will display individual columns for the top 10 values found in the field you use to execute your multi-series split. In this example, this would be the product name field. By adding the argument of limit, you can override that top 10 to whatever whole value you find appropriate. In the example shown, we can see that by adding limit equals 5 to our search string, it's resulted in only having the top 5 values for product name appear as their own individual column. Any values less frequent than the top 5 get aggregated into the other column. Please note that the limit argument sets a limit across the entire data set. It does not give you the top 5 in Canada and then a separate top 5 in the United States, for example. If you want to remove any limit on the number of columns shown, use limit equals 0. Splunk will then give every possible value for your multi-series split field its own column. If the column split has too many values to display in the visualization's legend, the list will include a down arrow to scroll through the values. You can further control the columns shown with the useOther and useNull arguments. The useOther argument will completely remove the other column from your results. Please note that this is only a visual change. This does not recalculate the original results that were generated by your base search. The useNull argument will remove the null column if one exists. The null column will contain the statistical valuation of any events that did not actually contain the field that the multi-series split was based on. In this example, a null column would have been present if any of the events in the initial search returned did not contain a value for the product name field. Here are some additional examples of the chart command. We can see here that our count of events returned by our base search has been subjected to a single series split. We have split that count by the values found in the vendor action field. Here, we see a multi-series split. We have first counted our events by vendor action, and then have further refined our table to split those actions by the different users who took them. Note that in this example, we are not using the over and the by clause, but simply a single instance of the by clause itself. The last report was skewed by surplus categories. By using the useOther equals F argument, we have been able to remove these categories from our report. The span argument allows for arbitrary grouping of values on the x-axis, as long as the x-axis is numeric. This can group events into buckets. Splunk shifts overlap values to the higher grouping. For example, a status code of 400 would have been bucketed in the 400 to 500 range, as opposed to the 300 to 400. In this example, the IT manager wants to see the volume of web activity over the last 24 hours by ranges of status codes. Without the span argument in place, each possible HTTP status code would have been given its own space on the x-axis, possibly resulting in an overly busy chart. The time chart command performs stats aggregations against time. Time is always the x-axis. With time chart, we can perform statistical aggregations against time and return a time series chart or table. The function we choose will determine what populates the y-axis of our chart. The x-axis will always be split by time. As you can see, the syntax for time chart command is very similar to chart. Functions and arguments used with stats and chart can also be used with time chart. Like with the chart command, we can choose to split our results table. A key difference between chart and time chart, however, is that time chart only supports a single additional split. This is because our x-axis is automatically segmented or bucketed based on time when using the time chart command. We can further control time chart behavior by using the span and limit options. In this example, we've been asked how many events have been logged onto the Cisco Web Security Appliance in the last 7 days. We could simply count the number of events with the chart count command. However, this doesn't show us how that count is split over the last 7 days. For that, we should use the time chart command. We can see here that our leftmost column becomes split by time, and our rightmost columns are an aggregated count within each time bucket. This can be best represented as a line chart visualization. but you are free to use other visualization types if you choose. In this follow-up example, the security team wants to see the previous report but split by the different types of usage. In this case, the values in the field usage become the different series shown on the time chart. The functional equivalent search using chart would be pipe chart count by time, usage. But time chart automatically applies a bucket command to set the time span to a preset sampling interval. Remember, you can only split by one field with time chart. When using the time chart command, Splunk will automatically decide what the appropriate buckets for the values of the time field will be. It does this based on the time range of your search. For example, using the time chart command for a search over the last 24 hours will make Splunk aggregate the results into 30-minute buckets. A 60-minute search will aggregate results into 1-minute buckets. We can see this reflected in the stats table output by the search in this slide. Each row represents a chunk or bucket of aggregated data. It's possible, even common, that you may not find the time period Splunk uses in this process appropriate. If that's the case, you can override Splunk's bucketing choice by using the span argument. By putting span equals some period of time, you can force Splunk to group buckets based on the time range that works best for you. In this example, we can see that putting an argument of span equals 15M forces Splunk to group data into 15-minute buckets. We can also use the limit argument with time chart in order to control the number of values returned to us for our multi-series split. In this slide, we've been asked, what was the top total web sales for the top 5 products during the last 24 hours? From the search syntax, we can see that we have chosen to aggregate our data into 1-hour buckets with the span equals 1H argument. Our statistical function in this case is sum, and the field we are getting for the sum is price. This means that we are getting a sum of all the values in the price field. We are then splitting our data by the values found in the product name field. Without the limit argument, we would have had the top 10 products returned to us, with 11 lines on our chart, 10 for our products, and 1 additional series for other. By adding limit equals 5, however, we are returning only the top 5 values for product name, along with, of course, other. The time chart and chart commands both take advantage of the same statistical functions. You can equally use count, sum, average, just to name a few, in either command. All commands supported by chart, time chart, and stats can be found in the search manual online in our documentation. In this slide's example, we can see that we're asked what was the total web sales for our top products during the last 24 hours. Let's show a quick example of the different ways that time chart treats time compared to chart. We're looking at access combined data. Let's see what happens when we split our data using the chart command, but with time as our primary series. Here, we can see we're running a multi-series split with time as our principal split value. Notice the bucketing in the left. There is none. Every time we see a different value in the host field, Splunk considers that a separate series. We can see that the time has no aggregation whatsoever. Anytime there's a host, we get a new row. Let's contrast this with how time chart aggregates data into buckets. Here, we can see how the time chart command has allowed us to aggregate values in the host field based on time, as opposed to the chart command, which gave each host value its own time bucket. When running a multi-series time chart, we have an option in how we want our data to be displayed. Given multiple values in our multi-series split, our time chart can sometimes appear more cluttered than is useful to us. Because of this, we have the option to toggle a feature called multi-series mode. This mode defaults to no, which gets us a time chart as we can see here. If we click on the Format button, however, we have the option to turn multi-series mode to Yes. This will separate out our different values into their own lanes on our chart. They share the same x-axis, but at this point they all have their own individual y-axis, almost like their own swim lanes. Toggling this mode to Yes can be useful in clearing up order of activity in your data. Note that with multi-series mode, although the different values now have their own y-axis, each one is still uniform in its ceiling and floor. The top command finds the most common values for given fields in a result set. Let's take a look at the syntax. The command starts with pipe top, followed by a list of fields we want to find the most common values for. We can also group results together based on shared field with the by clause. The top command will return a table with the top 10 most common results by default, but this can be overridden with the limit argument. The optional arguments that can be used with the top command are count field, limit, and show perk. In this scenario, we are asked to determine which IP addresses generated the most attacks in the last 60 minutes. Without any additional arguments, we can see that this search command returns a table which lists the top 10 most common IP addresses returned in our base search. We can see that a percentage is also included. This is because show perk will default to true. Here, we can see the limit argument being used. By adding the argument limit equals 5 to our top command, we limit the returned results for the SRC IP field to just the top 5 most common. This search asks us to display the top 5 IPs that generated the most attacks during the last hour. Another important aspect of the top command is the ability to find top values for specific combinations of fields by adding more than one field to our field list. Here, we can see that our table is showing results for the top 10 most common values in the CS username field. Let's add another field to this list. We can now see a new column. In our previous search, all values for the CS username field were unique. In this search, however, all combinations of CS username and webcat code are unique. The top command will return both a count and a percentage field by default. You can choose to toggle the percentage field, however, with the Boolean argument show perk. Setting show perk to false, F, or 0 will prevent the percentage column from being displayed in the resulting table. Count field is another argument that can be added to the top command. In this case, the count field argument allows us to rename the count column from the default of count to whatever string we choose. In this example, we can see that the count column has been renamed total viewed. We can also choose to group our results based on the values in a field. We do this with the by clause. Here, we can see that we are displaying the top 5 users for each web category. Here instead, we're displaying the top 5 web categories browsed by each user. The top command can also be run from the UI. By clicking on a given field in your fields list, you can choose to display the top values by simply clicking on the option shown. As you can see, this actually adds the top command to your previous search string. Note that when you use this method, the limit argument is set by default to 20. You can override this if you want. The rare command has the same options as the top command, but it returns the least common values of a result set. Essentially, the rare command is the opposite of the top command. In this example, we are looking for the product that had the least number of sales by Buttercup Games vendors in a given time period. Note that the same arguments and options available in the top command are also available with rare. To produce statistics from our search results, we can use the stats command. The stats command uses various functions to calculate statistics on search results. Your output in this case will be a table. You can also choose to group your results with a by clause. Unlike chart and time chart, stats allows for continuous splits of your data. You can group more than two fields together with the by clause here. The WC in WC field means that the stats command supports wildcarded fields. Like chart and time chart, stats support statistical functions. But unlike chart and time chart, stats can support multiple fields. In this example, we are asked to count the invalid or failed login attempts during a given time period. Note that we can rename the resulting count column with an as clause. If we do not choose to rename a field with the as clause, they'll be named according to the search syntax. In this example, we can see both a count of events that contain a value in the vendor action field, as well as the overall total of events returned in our base search. This slide further demonstrates how more than one statistical function can be invoked with the stats command. We can do this by separating the functions with commas. We can also see here how the as clause allows us to rename fields in line in our search. In this example, we're counting the total number of events that contain a value in the vendor action field and renaming that result as action events. We're further counting up the total number of events returned by our base search and calling this total events. In the event that we use multiple functions, it's a very good idea to make sure that we rename our results in order to eliminate confusion. As with chart and time chart, the by clause allows us to split our resulting table for stats based on the values in a given field or fields. The order in which the fields are listed has a big impact on the results. Your data will first be grouped by the first field given, then grouped by the second field given, and so on. Here's an example. In this table, we've first grouped our returned results by the values found in the user field, and then by the values found in the tag field within each user. Let's see what happens when we switch the tag and user values in the search. In this table, we can see our returned results are first grouped by values found in tag, and then grouped by values found in user. In the previous section, we used the count function to count the number of events that matched specified search criteria. Let's take a look at some of the other functions that are commonly used with the stats command. We've used two of the aggregate functions, count and sum, in our previous examples with chart and time chart. But there are many different functions that can be used with these commands. Broadly, these functions fall into one of four categories. They either allow us to aggregate values, sort on a dependent order of values, return multiple values from within a given field, or return values based on time. This video does not contain an exhaustive list of the possible functions to accomplish these tasks. Here's a small sample of some of the functions that can be used with the stats command. DC, or distinct count, for example, provides a count of the unique values for a given field in the results set. Here we can see the question was asked, how many unique websites have employees visited in the last 4 hours? Using distinct count, we can get the unique values found within a given field. Let's give an example of the sum function. The sum function calculates the sum of values within a given field, as long as the values are numeric. In this example, we're being asked, how much bandwidth did employees consume at each website during the past week? Let's first set our time range to the last 7 days. We can then use the sum function to begin calculating our bandwidth. Stats sum of the values found in the SC bytes field. We'll then split this by the values found in the S hostname field. Here we can see the different websites visited on the left and a sum of the values in the SC bytes field over the last 7 days on the right. Let's make our results a bit cleaner for our end user by renaming some of these values. We can rename some SC bytes as bandwidth to make it more obvious what we're measuring, and then we can sort on the bandwidth field from highest to lowest. Using a minus sign in front of the field you wish to sort, tell Splunk that you wish to sort in descending order, i.e. from highest to lowest. We can combine multiple functions within our stats command, as well as multiple commands within a search. Here's an example where we are asked to report the number of retail units sold and sales revenue for each product during the previous week. Let's first count the number of events that have a value in the price field. We'll call this field units sold. Within the same stats command, we should also get a sum of all the values in the price field, and rename this result total sales. Let's now split our results by the values found in the product name field, thereby giving us the number of units and the total amount of money made per product. Once this is done, we can sort our returned rows based on the values found in the total sales field. Again, the minus sign lets Splunk know that we wish to have this sort done in descending order. 3 more common functions that are used with the stats command are min, max, and average. Minimum will give you the lowest value in a given field, maximum will give you the highest value in a given field, and average will give you the average value in a given field. We can see here, we are asked what is the minimum, maximum, and average bandwidth used for each website usage type. The average function ignores any event or row that does not have a value for the specified field or has a non-numerical value for that field. The values function allows us to list the unique values found in a given field. In this example, we are showing all unique values found in the user field and labeling this as usernames. We then count all the instances that a value was found in the user field, unique or otherwise, and labeling this as attempts. We then split our result set by the values found in the SRC IP field. The resulting table shows us for each IP address what usernames can be found and how many times any username was present for that IP address. The list function lists all values found in a given field, including duplicates. In this example, we've been asked which websites has each employee accessed during the last 60 minutes. The list function can be quite useful for creating easy-to-read data tables. Note that if an event contains multiple values for a given field, that's fine. All values will be shown. Let's highlight the difference between the list and the values functions. On the left, we can see the list function being used. Every instance of a value within the shostname field is being displayed, even if they are duplicates within a given username. On the right, we can see that the values function will only display unique values for a field within a given username. Putting it all together, we can see how taking advantage of multiple functions within a single stats command allows us to pull some very powerful insights out of our data. Working with a simple result set from our base search, we are still able to set up a table that explores multiple aspects of our data. Here, we are only using values found in the price field and splitting that by the values found in the vendor country field. Even so, those 2 fields alone can tell us the amount of products sold, the average price it was sold for, the range of prices found in our products, among other insights. The chart, time chart, and stats commands share similar features, but it's important to use the proper command to get the results that you're looking for. Let's take a look at this chart describing the differences in usable arguments across all three commands. First and most important is the number of arguments you can split your results by when using the by clause. With chart, you are limited to 2 fields you can base your split clause on. With time chart, you only get 1. That's because time is automatically selected for you as your primary split. Stats has no such limitation. Also of interest are some of the arguments available to you with chart and time chart that are not available with stats. Limit limits the number of visual series shown in a multi-series split. Filtering out null and other also refer to visual elements that you may wish to remove. An x-axis also only is present when referring to some sort of visual chart. The rule of thumb to remember is that the end product of the stats command is meant to be a table, while the end product of the chart and time chart command is likely a visualization. This will help you remember which arguments are appropriate in each case. The eval command can be used to perform calculations with values in your data. Before we explore its specific functions, let's take a look at how it's used. An eval expression is a combination of literals, fields, operators, and functions that represent the value of your destination field. The expression can involve a mathematical operation, a string concatenation, a comparison expression, a Boolean expression, or a call to one of the eval functions. In essence, the eval command is allowing you to create a new field on the fly, with the values in that field being populated by the results of your expression. This field can then be used the same as any regular field for the remainder of your search. It's important to realize that nothing written with the eval command is kept after the lifetime of the search it was used in. This means that the new field you create is not saved to your index in any way, nor will it be available again after the search is completed. In addition to creating a new field, the eval command can also be used to temporarily overwrite the values present in a previously existing field. In this case as well, no change to your data is permanent. The new values are not written to disk in any way. The eval command supports various operators in the expression of your statement. For arithmetic, we have addition, subtraction, multiplication, division, and modulo. For concatenation, we have a plus and a dot operator. The plus sign will concatenate any strings or characters. The dot sign will concatenate any data type. The expression also supports the AND, OR, NOT, and XOR Booleans. And we have our various comparison operators as well. Less than, greater than, less than or equal to, greater than or equal to, not equal to, and like. The eval command does require some fairly strict syntax that you should be aware of. For example, field values in the expression of an eval statement are treated in a case-sensitive manner. This is separate from how they are treated in a base search. String values should also be double-quoted in every case, even if the string is only a single word. Field names, as opposed to field values, must be unquoted or single-quoted if they contain a special character like a space. Also, remember to use a period instead of a plus sign when concatenating a string with a number in order to avoid data type conflicts. Let's give some examples of eval in action, as well as showing some of the different ways to write an eval statement. In this example, we've been tasked by the network team to show the number of bytes used by website type over the last 30 days. Now technically, this search satisfies that question. On the left, we can see the different types of websites visited, and on the right, we can see the number of bytes spent on each. However, this might not be a very useful result. It would be nice if we had a field such as kilobytes or megabytes. That's not available in our raw data, but we can create one with the eval command. I'll create a new field called bandwidth. The values in bandwidth will be as follows. The values in our bytes field divided by 1024 divided by 1024 again. This would give us the number of megabytes used in the same period. As stated before, we can use the eval statement multiple times on the same field. So let's do so to get rid of some of these decimal places in bandwidth. I'll call eval on bandwidth again, and this time I'll use a function called round. Round takes two arguments. The first is the number or the value you wish to round. The second is the number of decimal places you wish to round to. That's a much more readable chart. When we're done with this, I can actually remove the bytes column from my table as it's no longer useful to me. Another important point to recognize is that these two eval commands could have easily been accomplished with a single statement. Let's combine the two now. We can easily support functions within our expression. Another way we can accomplish this is by calling more than one eval statement within the same command. So let's split out these two again and see how this could be accomplished. I'll leave our initial value for bandwidth in place, but then I'll call bandwidth immediately again. Same result. Once we've created a new field with eval, that field can be referenced in the search pipeline later on. In this example, we've created a new field called bandwidth. We can immediately run other commands against that new field, things like sort or rename, or even perform a single or multi-series split with our new field. As we can see in this example, we can link more than one expression together to create multiple fields. And this can be done within a single eval command. Here we can see we've created a new field called current discount with the eval statement. Within the exact same eval command, we are then using current discount as a reference point for the expression in a new field called new discount. New discount is then used in the expression of a new field called new sales price. In the end, all of our fields are listed in the table. This can be useful when we need to show values step by step along the way as we convert. Eval functions allow you to convert, compare, and perform mathematical calculations on values in your data. There are too many expressions to go over them all in this module, but I have added a link to a comprehensive list in your notes. Let's take a high-level look at some of the most commonly used eval functions. Evaluation functions will evaluate an expression based on your events and then return to you a result. Now, this is not necessarily true for all functions in eval. Some do not evaluate any expressions, but instead return a result based on their own functionality. There are 11 different categories of evaluation functions. Some will convert values, some will compare values, some will perform mathematical operations, some will perform statistic operations, others will transform text, and many more. Here's a small sample of some of the functions available with the eval statement. For example, round will round x to y decimal places. Otherwise, if not given an argument of y, will return x as a whole number. Pow, for example, will return x raised to the power of y. We also have some statistical functions, such as minimum, maximum, and random. Here's an example of the pow function. In this particular case, we've created a new field called bandwidth. The expression that informs us of the values of bandwidth is the following. The values in the field of bytes divided by 1024 raised to the power of 2. In this example, we can see that power is given two arguments. The first, x, is the number we wish to raise, 1024. The second, y, is the number of powers we wish to raise it to, in this case, 1024 to the power of 2. The round function is also extremely commonly used. For round, we will take x and round it to the decimal places specified by y. In the example shown below, on the right-hand side, we can see the field of bandwidth has many decimal places, probably more than we need. By calling eval bandwidth equals round and passing round the arguments of bandwidth and 2, we can see that we have rounded bandwidth to 2 decimal places. It's a common practice to wrap the round function around the results of another statistical function. This way we make sure that our end result of the entire process is human readable. Max, min, and random, although perhaps less commonly used than pow and round, can still be incredibly useful. The max function will take an arbitrary number of arguments, either numerical or string, and return the maximum one found. Minimum is the opposite. Minimum will also take an array of numeric or string arguments, but it will return the minimum found. Random takes no arguments. Instead, when called by itself, it will return a pseudo-random integer ranging from 0 to 2 to the 31st minus 1. Here, we see a slight variation of the classic dice roll example of random. We're creating a new field called group, and the values in group will be as follows. The output of the random function to the modulo of 5. We then add 1 to make sure that our result cannot be 0. This will give us a random number between 1 and 5. We're then choosing to list the values in the user field as users by group. This would allow us to create 5 random groups of users. The eval expression can be used without functions. It doesn't necessarily require a function. Here we can see the creation of a field called discount. The expression that informs us of the values in the discount field are TLP minus TSP divided by TLP. No function necessary. Later on in this same search, we can see eval on discount again, and in this case, we're simply concatenating the current value in discount with a percentage sign. The eval command can also be used as a function with the stats command. In this example, we've been asked to count the number of events that occurred in a given time period where the vendor action was accepted, failed, or session opened. Here we're using eval as a function within the count function. The search is as follows. Give me a statistical analysis and count events where, now we eval, where the value of accepted is found in the field of vendor action. Relabel that a field called accepted. Further count where the value of failed is found in the field of vendor action. Call this a new field called failed. And finally, count all the events where a value of session opened is found in the field of vendor action, and call this a new field called session opened. This allows us to arbitrarily group values together that would otherwise be seen as multiple different splits. This does require an as cause to rename the newly created field. There may be times when you want to display a more meaningful or user-friendly name for a field. To do this, we use the rename command. Renaming a field is fairly simple. We can use the command pipe rename, then the name of the field as it currently exists, followed by the as clause, followed by the new name we wish to give to the field. If your new field name contains special characters or spaces, be sure to use double quotes to encompass the entirety of your new field name. Here's an example where we rename multiple fields within the same rename command. Here, we have first chosen to rename the product ID field as product ID with capital P and capital D, followed by a comma. Then we rename the action field as customer action. And finally, we rename the status field as HTTP status. This slide also points out a nice example that your clauses, such as or by, do not need to be upper or lower case. These are in fact case insensitive. Note also that as customer action and HTTP status both contain spaces in their field names, we need to encompass the entirety of these field names with double quotes. Once a field is renamed, Splunk will only respond to or be able to use the new name of that field for the rest of your search. The example on the left shows what can go wrong. In this particular case, the user has renamed the action field as customer action and the status field as HTTP status. They then ask to give a table with the field's action and status. However, since these fields were renamed, Splunk no longer recognizes that there was ever a field called action or status. On the right-hand side, we see a better example. In this case, the user has further called a new command, sort as opposed to table, but this user has made sure to use the new names given to each field. As such, Splunk has no problem creating this table. We can also use wildcards to rename multiple fields that match a pattern. In this example, we've renamed the fields product ID and product name by changing product wildcard to prod wildcard. When we then base a table on prod wildcard, we can see that both of our original fields will appear. The sort command allows you to display a field's values in ascending or descending order. The syntax for the sort command is as follows: pipe sort followed by a minus or plus sign. This will determine whether you are sorting in ascending order by default with the plus sign or in descending order with the minus sign. The plus sign is implied, so you don't have to use it deliberately. Follow this with the field or fields you wish to execute the sort based on. If the field name on which you're sorting contains spaces or non-alphanumeric characters, be sure to enclose it in double quotes. Finally, if you only want a certain number of results, you can use the limit equals argument, or just put an integer representing the number of results that you want. Splunk will then determine the data type present in your field and sort appropriately. Alphabetic strings will be sorted lexicographically, numbers will be sorted numerically, and so on. Note that the sorting of alphabetic strings is done lexicographically as opposed to alphabetically. This means that uppercase letters appear before lowercase. We can see this in the example shown here, where BEE with a capital B gets placed before ANT with a lowercase a. In this example, we are asked to display vendor information for vendors that begin with BEA. We have our table already set up. We now just need to sort. Let's sort our rows based on descending order in the vendor field. Note that we have a space between the minus sign and the field that we're sorting by. This space can become important if you want to sort on more than one field. Let's take a look at the difference in two examples. First, let's add a comma and then another field to sort by. How about vendor city? Since we have a space between the minus sign and the first field in our list, the descending order instruction is applied to all fields in the list. We can see this in the vendor city values listed for the Beach Games vendor. Miami comes before Fort Lauderdale because descending order is applied in both cases. Contrast this with how results are sorted if we have the minus sign immediately next to our first field. In this case, we are telling Splunk to sort the vendor field in descending order, but then to sort vendor city in ascending order. Here, Beach Games still comes last in the vendor column, but now Fort Lauderdale comes before Miami in the vendor city column.
Hello, welcome to the Comparing Values Learning module. I'm Jessica with Splunk Education. In this module, you will learn how to compare values in your data using conditional statements and commands. We'll begin with the eval command. The eval command calculates an expression, then puts the resulting value into a new or existing field, which can be reused in the search pipeline. Now, if we are using eval with a field that already exists, the eval command will overwrite the values of the field with the results of the eval expression. This is done at search time, not changing or overwriting any of the already indexed data. If we are creating a new field with the eval command, it will take the values of the expressions, but again, no new data is written into the index as the eval command operates at search time. Now, the eval command supports various operators that can be used in the expressions, ranging from arithmetic operators, comparison operators, to concatenation operators. There are two types of concatenation operators, as we see here, the plus operator and the period operator. The plus operator accepts two numbers for addition, or two strings for concatenation. The period operator concatenates both strings and numbers. Numbers are concatenated in their string represented form. Now, the eval command treats values and string values in a certain way where the syntax needs to be specific. So if we take a look at an example here and we run a search, let's say across our retail sales data, and we're looking at the retail sales of the United States. I'm going to run this search across the last 24 hours. And what we'll notice here is we have our price field in the sidebar. We would like to compute a sum of our price per state and display that information in a table. I'm going to pipe to the stats command, sum up the price field, name that sales, and split by vendor, state, province. That will take me over into a 2-column table, and I'm going to create a brand new field using the eval command called performance. This is not a pre-existing field. I'm creating a brand new field and setting that equal to the case function, which is going to take a Boolean expression that returns to true or false as the first argument. So what it will evaluate for is whether the value of sales is less than or equal to 500. The field of performance will be equal to a value of needs immediate evaluation. Field values that are created using the eval command are treated in a case-sensitive manner. So needs immediate evaluation can be one of the possible values. Now, another Boolean argument that we can pass in is whether the sales value is less than 1,000. In this case, performance will be equal to a value of underperformer. If sales is greater than or equal to 1,000, it will take a value of overperformer. And we will run this search and see performance added as a column to our table, depending on what the value of sales is in that specific event. Now, field names must be unquoted or single quoted when they include a special character like a space. So we can see that when we're using these field names in the eval command, such as sales, it is unquoted. And I can go ahead and create one more field here with the eval command by either chaining an expression with a comma or by piping to a completely separate eval command, creating this field of verdict, setting that equal to the if function and saying if performance has a value in this list of underperformer, needs immediate evaluation, then we are going to set verdict to send to marketing or take the value of null. All right, we'll run that search. Verdict will be added as a column to the table, and we can see the empty cells are null values. And then lastly, we are going to add a $sign in front of these sales values because they represent monetary values. I will set sales equal to, concatenating a $sign to the front, converting sales to a string, adding commas where necessary. And one thing about concatenation with the eval command is to use a period instead of a plus symbol when concatenating strings and numbers to avoid conflicts. Now, there are multiple different ways to write eval expressions. We can pipe to separate eval commands, which adds more lines to your SPL. We can include the function and the expression as an argument to that function, containing everything within one single line in one eval command. Or we can comma separate the two eval expressions all within one single eval command. This showing that evals can be separate, they can be nested, or linked with a comma, all resulting in the same table. Now, if we create temporary fields using eval, such as the bandwidth field, those can be referenced in the search pipeline by any commands following that. We can sort the values in descending order, for example, and rename them. They will be treated just like any other field. The eval command can use functions to evaluate an expression based on your events to return a result. There are 11 categories of functions that can be used with the eval command. These functions range from comparison and conditional functions, informational and statistical functions, to conversion and multi-value functions that can be applied to multi-value fields, and a lot more. If we zoom on into comparison and conditional functions, a few of those functions are listed here. Now, this is not a full list. These are just a few of the comparison and conditional functions that we can use with the eval command and that we will look at over the course of this module. The case function is going to evaluate multiple Boolean expressions and return a value based on these multiple else-if statements. The CIDR match function is going to return true or false based on whether an IP falls within a subnet range. The if function is going to evaluate a single Boolean expression. If that's true, it'll return the value of the second argument. If it's false, it'll return the value of the third argument. And the like function is going to typically be used with something like a wildcard or evaluating whether the string matches whatever argument is passed in as the pattern. The in function, as we saw, returns true if the value list matches a value in the field. And then lastly, match is used for matching on a particular regex pattern embedded within the subject argument. Now, these functions here are fairly straightforward. We have the true and false functions and the null function, which returns the value of null. Null if will return a value of null if the value of the first argument is equal to the value of the second argument. Otherwise, it will return the value of the first argument. Validate function is actually going to be the opposite of the case function in that it will return the second argument of y for the first expression that evaluates to false instead of true. And then lastly, search match returns true if the actual search string passed in to that function matches the event. So with all of these functions, we can use them within the eval command, but they can also be used as part of the where command and the field format command. Most of these eval functions can be used within the eval expression for these different commands, and as part of eval expressions within the function of eval embedded in a function of the stats command. The if function takes 3 arguments: a Boolean expression, an argument to return if the Boolean is true, and another to return if the Boolean is false. Let's take a look at an example of the if function and how it works. Running a search across our retail sales data, index equal to sales, source type of vendor sales. If we take a look at the field sidebar, we do not currently have a field named sales territory. We have a field named vendor ID, and the values of vendor ID pertain to different regions. We would like to create a new field called sales territory using the eval command with the if function of the eval command. This if function takes 3 arguments. The first argument is a Boolean expression that returns to true or false. This is going to contain the vendor ID field that will evaluate within each event if the vendor ID is greater than or equal to 7,000 and less than 8,000, we are going to take the value of the second argument. So if the first argument returns to true, that means that the sales territory is in Asia. Otherwise, it is in the rest of the world. Once we run this search, sales territory will be added to the field sidebar. We can make it a selected field, and it will display along the bottom row of each event, the value being set depending on what the value of the vendor ID field is in that specific event. From here, we can go ahead and possibly display what the total revenue is per sales territory using the stats command, and then possibly formatting these values by concatenating a $sign to in front of the total revenue and converting it over into a string, adding commas where necessary. With the case function, we can enter multiple Boolean expressions separated by the argument of what to return if the previous expression evaluates to true. Only the argument for the first expression that evaluates as true will be returned. If none of the expressions return true, an empty value is returned. The case function takes in multiple Boolean expressions and possible values. We can see here that if x1 is true, it will return the second argument. If x1 is false, then it will evaluate over to the next expression. If none of the Boolean expressions evaluate to true, case will return null. Now, taking a look at an example, in this search, we're searching across the network index, source type of Cisco WSA Squid. We're creating a new field called risk and evaluating whether the value of this field is greater than or equal to 5. If so, the risk field will be equal to a value of 1 very safe. If not, we'll go over to the next set of Boolean expressions. We can see here we have different results with a null value as well, visualized within this visualization. If we would like to exclude any null values, we would have to add a condition that always evaluates to true at the very end of our case function. That can be done either using 0 equal to 0, using the true function of the eval command, where in this example, if status is not equal to 200 or 404, instead of returning null, the true function will be evaluated. It will always return true, and description will be set to a value of other. Now, if we take a look at an example search, let's go ahead and explore our data within 2 different source types, starting off with our web data with the source type of access combined. Taking a look at the field sidebar, we see a field here that contains IP addresses called the client IP field. Now, if I make my way on over into my network index, source type of Cisco WSA Squid, I'll notice in the field sidebar that I have a field called C_IP that contains IP addresses. I would like there to be a consistent naming convention for these field names across these two different data sets. So what I'm going to do is run a search across both index equal to network or index equal to web, source type equal to access combined. Verify that I am getting results from two different source types, and then create a new field with the eval command called unique IP equal to the case function. If the source type within an event is equal to access combined, then unique IP will take the value of the client IP field in that event. Otherwise, if the source type is equal to Cisco WSA Squid, unique IP will take the value of the C_IP field. Once we run that search and we take a look at the field sidebar, we are going to have a newly created field of unique IP, which will be a combination of those two fields. And we can see here the source type was access combined. So unique IP is set to the value of the client IP. The validate function works exactly like the case function, except instead of evaluating whether or not a statement is true, it returns an argument when an expression evaluates to false. As we can see, the validate function takes multiple arguments, just like the case function. However, difference being, the returning value will be dependent on the first expression that returns false. In this example right below, we're looking at our Linux secure logs, creating a new field called port warning, and we are going to validate whether source port is greater than 0. If that returns false, we will take the value of error, port is not a positive integer. If that returns true, we will move on over into the next expression. We'll validate whether the port values fall within this range. If that's not the case, we will take the value of warning, port is out of range. And if neither of those return false and all expressions return true, then port warning will be set to a value of null. The in function allows you to evaluate a value from a field against a list of possible values, and returns a value of true if it finds a match. As we can see here, the in function is passed in as an argument of the if function of the eval command. The in function will return true as long as the values within the value list match a value from the field passed in as the first argument. Let's take a look at an example. Running a search across index equal to web, source type equal to access combined, we are going to notice in the field sidebar that there's currently not a field named error here. I will create that new field using the eval command and setting that equal to the if function. First argument will be the in function, which will verify whether the status field within each event is equal to a value of 404, 500, or 503. If that's the case, error will take the value of true. Otherwise, it will take the value of false. We will run that search, take a look at the error field in the sidebar, make it a selected field, and we will take a look here. We have a status of 200. Error is set to false because 200 is a successful status code. However, 404 will take a value of true for that error field. Now, one thing to mention about the in function is that it has to be used within the if function or case function with the eval command. However, it does not need to be used with the if function or case function if it is used with the where command. The eval command can also use a series of matching functions to return true or false values if a supplied condition is matched by returned values. Let's start off with the search match function. The search match function is a function of the eval command that must be embedded within the if function of the eval command, and it will return true or false depending on whether an event matches the search string passed in as an argument to the search match function. Let's go ahead and take a look at an example. If we run a search across our games data within the games index, source type of SIMQ beta, we are going to create a new field using the eval command called match result. The match result function will be set to the if function, which will contain the search match function as its first argument. The search match function accepts a string as an argument, the string being a case of the Mondays. So if this search match function returns true, where this string exists in an event, the match result field will have a value of found. Otherwise, if this returns false, the match result field will have a value of not found. If we run this search and we take a look at our field sidebar, we now have a field called match result that has those two values. 48 of those events have a value of found, and we can take a look at those events and notice got a case of the Mondays is embedded as a string within these events. Now, along with the search match function, another match function that we have available is the CIDR match function of the eval command. The CIDR match function will also return true or false. This is dependent on whether the IP address that's passed in falls within the CIDR subnet range. We can see the CIDR range is passed in as the first argument. Field containing the IP addresses is passed in as the second argument. If an IP address stored within this BCG IP field within an event matches this subnet, CIDR match will return true. IsLocal will take a value of isLocal sub2. Otherwise, it will take a value of not local sub2. And then lastly, we have the match function. The match function is going to use regular expressions to match on the first argument. It'll return true based on whether the subject matches the regex. In this example here, we're using the values of the source field. If this regex matches the values of the source field, match will return true, otherwise it will return false. Match can be made to behave like the search match function. Difference here being passing in underscore raw as the first argument of the match function and the string used for search match as the second argument. So if we replace this search match function with the match function and we pass in underscore raw as the first argument, got a case of Mondays as the second argument, we are going to run this search. This will be a valid argument in terms of that second argument there, because this is a literal string. These are literal characters within regex. And so what we'll see here is match result will return the same result when using this match function versus the search match function when passing in that same string as the second argument and underscore raw as the first argument. Search match by default works off of the raw data. The field format command can be used if you want to format values, but not change the characteristics of the underlying values. Field format uses the same functions as the eval command. The field format command uses a variety of the functions that we've discussed so far as part of the eval command. Field format will accept a field equal to an eval expression, and the field format command will alter and change the format of a field's values with that eval expression, only changing the appearance, not the actual value stored within that field. Once these results are formatted, they cannot be modified by any subsequent commands. Let's take a look at a scenario. The IT ops team wants to know how many events were logged for each source type in the security index. We want to reformat values so that they have commas. Let's take a look at an example. Running a search across the security index and piping to the stats command, getting a count of events, and taking a look at the count of events by source type, we will name the count column total count. So here we can see all of these source types that pertain to the security index, and we would like to format the value stored in total count to a string, passing in total count as the first argument of the toString function, adding commas where necessary. These are now formatted, and we can see the toString function is a function that we're familiar with using as part of the eval command, but it is also supported by the field format command. The where command also uses the same expression syntax as the eval command, but filters events to only keep the results that evaluate as true. The where command is a command that supports eval expressions. It can be used with multiple different functions of the eval command, but it's also often used in comparison to the search command, difference being the where command allows for field-on-field comparison. The where command allows us to use mathematical and Boolean operators to evaluate values within the eval expression, returning true or false, returning results that evaluate to true, and treats field values in a case-sensitive manner. Here we have a list of the mathematical operators as well as the Boolean operators that are supported by the where command. And if we take a look at an example here, let's say the sales ops team wants to know which days during the previous week have seen more remove actions than change quantity actions. In this example, we're going to go ahead and run a search across our web data. And we'll notice that we have a field in the sidebar called action. Now, the sales ops team wants to know which days during the previous week have seen more remove actions than change quantity actions. And that's going to be displayed over time across, let's say, the last 7 days. I'm going to expand my time range to the last 7 days and pipe to the time chart command. Within this time chart command, I'm going to count and evaluate where action is equal to change quantity, name that changes, and count and evaluate where action is equal to remove, and name that removals. That's going to take us on over into a table displaying the changes and removals across the last 7 days. And I would like to filter on which days were removals greater than changes. If I were to pipe to the search command and specify removals greater than changes, this would return no results because we are comparing two fields. The search command does not support field-on-field comparison, so we will replace the search command with the where command, which filters on the 23rd and 24th being the days where removals were greater than changes. Now, the Boolean operators supported by the where command are and, or, and not. These Boolean operators should be in all uppercase, and these are evaluated in a specific order within an eval expression that's part of the where command. Everything within parentheses will take highest precedence, followed by not clauses, and clauses, and or clauses. Now, we can also use the where command to force case-sensitive searches. If we were interested in searching across events that contain a category ID with the value of strategy in all uppercase, that will return all of those specific events. Now, if we run a search with category ID equal to strategy all lowercase, that will return no results because this is a case-sensitive search. Now, the where command has its own wildcard that is separate than the one that is used with the search command. The search command uses the asterisk symbol as the wildcard. However, the where command has two wildcards, a % symbol to match on multiple characters, or an underscore to match on a single character. We can use the like operator or the like function to match on a range of values using these wildcards. One example here is we may be interested in a list of user accounts that are like admin. So we will use the where command with the like function and return all values of user that begin with ADM followed by anything else. We can return the exact same set of results using the like operator, specifying the name of the field to the left of that operator, and the string with that wildcard on the very right-hand side. This reads more like a function. This reads more like English, where user like anything that begins with ADM, where like user anything that begins with ADM. Whichever one is used is okay. It really just depends on user preference. Now, let's say that a sales campaign manager wants to know which 1-hour sampling periods contain no sales over the last 24 hours in Canada. Well, in this case, we could go ahead and run a brand new search, this time looking at our retail sales data. And piping to the time chart command, collecting a sum of our price, and we want to display this information in 15-minute intervals. In this case, we're looking at 15-minute intervals, but if we were interested in, let's say, 1-hour periods or 15-minute periods that contain no sales, well, we could go ahead and pipe to the where command and say, is null, pass in the sum field, and that will filter on any 15-minute intervals where the value was null. Looks like we don't have any, so let's go ahead and change the span here to 1 hour. All right, so here we're looking at our retail sales, computing a sum of price, and across the last 24 hours, it looks like we don't have any particular hours where we didn't have any sales. Let's go ahead and expand our time range to the last 7 days. This time adding is null sum back to our search. And now noticing that we have several 15-minute periods that had no sales. The is null function or is not null function will filter fields with null values within our results. Hello, welcome to Result Modification. I'm Jessica with SPLUNK Education. In this module, you'll learn how to modify result sets, manage missing data, and normalize data using commands and functions. We'll be looking at some examples using data sources from the fictional company Buttercup Games. Let's start with the append pipe command. The append pipe command will allow us to take existing results and push them into the subpipeline, meaning the results of the search specified in the append pipe command are appended to the end or bottom of the outer result set. If we take a look at the syntax of the append pipe command, we can see that it is preceded by a search and then followed in square brackets by the subpipeline. The results of this search, wrapped in brackets, are what are appended to the results of the outer search preceding the append pipe command. Let's take a look at an example here. Let's look at our internal network and make sure we are looking for connections to the internet that are not business usage and count this based on usage and username. We'll go ahead and run a search across our network index, source type of Cisco WSA Squid. And if we run this search and take a look at the field sidebar, what we will notice here is that we have a field named usage with 5 unique values, one of those values being business. We would like to exclude those connections to the internet that are not business related. Therefore, we are going to add usage not equal to business into our search and filter. From there, we want to get a count of events split by these 4 usage types and usernames. We'll pipe to the stats command and get a count of events by usage and username and display that information in a table. Now, I want to know in total for each usage case how many visits there were. We can see here we have for each usage and username combination, but I would like to see the overall picture of usage counts. What I could do is remove username from the stats command. This is taking out the counting of permutations based on usage and user. But now I can't see which users are using which usage types more than others. I just see the overall count per usage type. How do I get that in between? How do I count this based on usage and username and perform subtotals? Let's add username back into the stats command. And let's say that we attempt to use the stats command and get a sum of count, split that by usage. But again, my usernames disappear. So what I'd like to do is I would like to take this table that we're currently looking at and append it to this original table. That will be done using the append pipe command. And I will put the append pipe command right after the stats command. And within the append pipe command in square brackets, specify a subsearch, which is going to begin with a stats command and will sum up the values stored within the count column and split that by usage. Once I run this search, we will now see a column added to the table named sum count. And notice we have a bunch of empty cells here. If we move across each page and make it to the very last page, we can see the totals appear at the very bottom. This is displaying that the values are appended to the very bottom and end of this table. Now I'd like these subtotals to appear underneath the count column. Therefore, I'm going to rename this sum count column to count. I will do that in the stats command. Following the sum function, I will add the as clause, followed by count. And what that will do is append those subtotals to the very bottom of that table underneath that count column. Now, ideally, I would like these subtotals to appear in the right place where I have the subtotal for borderline usage types, personal usage types, unknown, and violation at the end of each section. So in order for these to be rearranged within the table, I need to resort all of the names or rows based on usage. So what we will do here is pipe over to the sort command and sort based on usage type, displaying the subtotals for each usage type at the end of that section. Here we have the subtotal for borderline, we will see the same thing for personal usage types, along with unknown and violation. Now I see these empty cells that appear for each subtotal row, and I don't have a good label for this. This empty row that doesn't have a user name, I would like to name based on its subtotal. As we know, we are appending a table to our original table, which has a count and usage. I need to create a new field called username, since we already have that here, that will be set to the label to fill in these empty cells, so that the labels will show up underneath this column and be set for these subtotals. So what we will do in the append pipe command is pipe on over to the eval command. Set username equal to subtotal of usage for, and then concatenate the value of the usage field in that row. If I run this search, we will now have a label for each subtotal. I can see subtotal of usage for borderline. I will see the same thing for personal, unknown, and violation. So we went ahead and added a stats and eval command to the append pipe command. And a search can contain more than one append pipe command. So before we send off the report, we decide to add a grand total to the end of the report. Now, in order to add a grand total, this is going to require following this sort command with an additional append pipe command that is going to search for the values of username that begin with subtotal of usage. And from there, we are going to sum up these subtotal count values. So what we will do is pipe to the stats command sum count as count and give that a name. Before we even provide an additional eval command, let's run this search. Let's jump on over to the very last page and we will see an overall grand total at the very bottom, which is the total of all of these subtotals. I'm going to provide a label where this empty cell appears, adding an eval command to this second append pipe command where username is equal to the overall grand total. And if we take a look at the very bottom of our table, we can see that label appearing. The event stats command will generate statistics for fields in searched events and save them to a new field in the results. It is similar to the stats command, except the statistics are added in line to pertinent events. Like the stats command, the event stats command computes requested statistics. But unlike the stats command, it also aggregates those statistics to the original raw data, making them available for use in later calculations. The event stats command will allow us to generate summary statistics based on a table we already have, and it'll save the values into a new field. All of the functions that are applicable to the stats command are applicable to the event stats command. And let's go ahead and take a look at a couple examples. For a new campaign, the online sales manager wants to see which products are losing more sales than the average during the last 24 hours, visualized in a bar chart. Let's go ahead and take a look. Running a search across index equal to web, source type equal to access combined, and filtering on those events that contain a customer action of remove, the online sales manager wants to see which of those products are losing more sales than the average during the last 24 hours. If we pipe on over to the stats command, compute a sum of our price, name that lost revenue, and split that by product name, we will see a table with the list of products and the total lost revenue that we've received. Now from here, I would like to compute an average of the lost revenue field's values and store that in a field named average. Now what this will do is take me over to an entirely new table with the average numeric value. In order to compare which products are losing more sales than the average during the last 24 hours, I would need to copy this numeric value, go back to my previous search, and add a where command to filter on where the lost revenue is, let's say, below the average value. Let's go ahead and run this search, and we will see 7 of these products are below the average lost revenue. Now, the downside of having to compute the average with the stats command, copy that numeric value, and compare it to the total lost revenue of each product is that every time that the campaign manager needs a refresh, I need to go back and do this by hand. Ideally, I would like to ask Splunk to grab the average of revenue from the table and append it as a column to my current table, where instead of creating an entirely new table using the stats command, I can introduce the event stats command, use the average function, and pass in lost revenue as an argument, run this search, and notice that average is added as a column to the table instead of being added to an entirely new table. From here, I can go ahead and filter using the where command and figure out which products are below the average. We may need to start marketing these games that are below the average a little bit better. If we take a look at our visualization, we can display this as a bar chart. The average here can be displayed as a chart overlay, meaning that it will be displayed as a line chart overlaid on top of our bar chart. Now let's take a look at an additional example using the event stats command. In this second example, the sales team wants to know the lowest and highest sales totals during the previous week and on which days they occurred. We can put this information on a nice dashboard for them. We need to figure out which days have the lowest and highest sales. We can see trends of when our employees are coming into the office or when they're more productive, but we're going to go ahead and search on where customers successfully purchase something in the online store, compute those total sales, and then add the maximum total sale value and minimum total sale value as two columns in our current table, as opposed to creating an entirely new table with those two columns if we were using the stats command. From there, we are going to filter on where the total sales were the highest and lowest, and then reformat a few of these values. Let's go ahead and take a look at this search piece by piece. Filtering on successful purchases in the online store by setting action equal to purchase, status equal to 200. We are going to use the time chart command to compute our overall price split by time. This is done across the previous week. And we want to display the lowest and highest sales totals during the previous week and which days those occurred on. So if I were to use the stats command and display the maximum total sales and minimum total sales using the max and min functions of the stats command, that is going to create an entirely new table for me. If I replace stats with event stats, that will add those columns to my pre-existing table. So I will name the maximum highest and the minimum lowest. And I'm going to filter on where the total sales equal highest or lowest, which days that occurred on. And from there, I'm going to create a brand new field with the eval command called outcome, set that equal to the if function. Remember, the first argument of the if function is a Boolean expression that has to return true or false. If the value of total sales is highest, the outcome field will take a value of highest. Otherwise, it will take a value of lowest. From there, we are going to reformat this date stored in underscore time using the strict time function of the eval command, which will take underscore time as its first argument and display the day of the week. That will be stored in the day field. And we will then place day, outcome, and total sales as our three fields on this table. If we wanted to format total sales as a monetary value, we can do that using the eval command, concatenating a $sign in front, and passing total sales into the toString function, adding commas where necessary, and seeing that numeric value being formatted. Like event stats, the stream stats command will aggregate statistics to your searched events. The difference is that stream stats will do this in a streaming manner, or as Splunk sees the events in time. The stream stats command is related to the stats command just like event stats. It uses all of the stats functions. However, instead of looking at the overall table, it'll look at individual events as it sees them. Stream stats is appropriate for counting a trend line, creating rankings, and showing you the order in which things happen. We can see the syntax of the stream stats command is that it's followed by a stats function, a field passed in as an argument. We can rename that using an as clause and split by multiple fields. Along with that, we have a window option and a current option built into the stream stats command. The window option allows us to be specific about the number of events to use. This will default to 0, which will be all of the events. The current option allows us to include the current event in summary calculations, which is going to be the default behavior. If we set current to false, it will exclude the current event and use the field value from the previous result. Now let's start off with this example search where the sales team wants to monitor a moving average of the price of a purchase on the Buttercup Games website over the previous 100 purchases during the last 4 hours. Let's go ahead and change our time range here to the last 4 hours and specify our web index, source type of access combined, action equal to purchase, status equal to 200, and we're going to filter on events that contain a product ID field in them. Now the sales team wants to monitor a moving average of the price of a purchase on the Buttercup Games website, and we are going to place both time and price onto a table and sort time. And from there, pipe to the stream stats command to compute the overall average of the price of a purchase on the website. We want this to be called average order, and we want this to be done over the previous 100 purchases. So this allows us to be restrictive using the window option built into the stream stats command, setting that to a value of 100 and not including the current event in the summary calculations. Once we run that search, that's going to build out a table with the average order field added in. And if we take a look at our visualization as a line chart, we will see average order being displayed as a trend line there. Now that is just one way of using the stream stats command. In addition to using stream stats for counting a trend line, we can use it for creating rankings. Let's say internal users are complaining that they cannot reach remote FTP servers. We are going to run a search across our network data, Cisco WSA Squid, and let's say the IT team needs a report of recent users and their IP addresses by server. That report should span the last 4 hours and have the server with the most attempts listed first. All right, we have an action here of TCP refresh hit. We are going to exclude events with that action. And from here, pipe to the stream stats command to count and name this recent attempts by the IP address. Notice that doesn't take us straight into a table. The stream stats command will create a new field called recent attempts, count that by BCGIP, and we are going to, from here, list out C_IP as the number of attempts or as users, list the recent attempts, and the maximum split by IP. Now from here, we're going to sort num attempts in descending order, and rearrange our table to display BCG_IP, users, and recent attempts. And so we can see a ranking here for these IP addresses that pertain to these users. Who are those recent users' IPs by the specific server? If you run a search that includes nulls for some data, your results will display with empty fields. To make our results easier to read, we can use the fill null command. The fill null command is one of the easier commands to work with. It will fill any empty cells in your table with zeros by default. Otherwise, we can specify a string that's provided as a value for this value option built into the fill null command. If we take a look at an example here, we can see this table on the left-hand side has a few empty cells. If we pipe the search that generates this table to the fill null command, it will automatically fill those empty cells with zeros. If we'd like to be restrictive about which fields to apply fill null to, we can provide a field list at the very end of that fill null command. Let's take a look at an example. Let's say we want to look at our retail sales data and evaluate vendor sales by country over the last hour. I'm going to pipe to the chart command, compute an overall sum of my price over product by country, and display this information in a table. What I'll notice right away is that I have a lot of gaps in my table. I'd like to add this table to a dashboard, make it look a little more complete, and fill these empty gaps, which are null values, with zeros. In order to do that, I will pipe to the fill null command, and I will see those zeros automatically added. Instead of using zeros, I could also set the value option equal to a string such as no value. That will automatically fill those empty cells with this string value specified.
The bin command adjusts and groups numerical values into discrete sets, or bins, so that all of the items in a particular bin share the same value. Buttercup Games' vendor relations team wants a report listing products sold by vendors grouped by range of revenue over the last 7 days. They don't want to get overwhelmed with specifics. They just want an idea of what games sell at a given range of units. Groups of total sales from 0 to 1,000, 1,000 to 2,000, 2,000 to 3,000, and so on. We start our search by getting a sum of the total sales for each product and putting them into a total sales field. We pipe to the bin command using our total sales field as the argument. The result is a list of game titles and a range for the total sales of each game. The bin command converted the values of our total sales field to values representing the range the values fell into. We can give some order to these results, making the report easier to read. We pipe in another stats command using the list function to list the product names by the total sales field, followed by an eval command that will add a $sign to the sales numbers. Now we can easily see which products sell in which ranges. Bin also includes a span argument that lets us tell Splunk how we want the bins created. The ranges in our report are a little too general, and we would like to break them down further. Adding span to the search, we can specify the size for each bin. Here we are limiting the bins to increments of 500, giving us the right amount of detail to present to our team. The XY series command will convert statistical results into a tabular format, making them suitable for using in visualizations. You might be asking yourself, isn't that what chart and time chart are for? You would be correct, but what if you need to do additional processing of results after the initial statistical data is returned. That's where XY series can help. As an example, let's look at a report we have that uses the time chart command to get the number of bytes served by each web server every hour over the last 24 hours. The report is accurate, but what if we want to show the results in megabytes? Adding an eval command to create the megabyte field will not help, since the data is already charted and not available to us. Instead, in our table, we still see the bytes for each hour split across the 3 hosts. Let's change our search to use the XY series command. Since we are looking to have our data shown in 1-hour blocks, we use the bin command with a span of 1 hour. Using the sum function of the stats command, we get a sum of bytes by host for each bin of time. We use an eval command to convert the bytes to megabytes. We now have 4 columns of data: time in 1-hour bins, and host, byte, and megabyte totals for each. Notice that if we try to visualize the data as a line graph, we don't have data that is chart-friendly. To chart the data, we want to combine the bins of time on the x-axis, move the host data to become names for our y-axis data, and use the megabyte data as the y-axis data. To do this, we use XY series. We pipe our search into the XY series command, followed by the field to use on the x-axis, in this example, time. We then enter the fields to use to name the y-axis and data to use on the axis. We are using host and the field that contains the megabyte data. When we run the search, we can see that Splunk rearranged the data, and it can now be used in a chart. While XY series will allow us to put results into a tabular format for graphing, the untable command does just the opposite. It will take chartable tabular data and format it similar to stats output. This can come in handy when we want to further extract from and manipulate values after using commands that result in tabular data. Our partner manager is asking us to build a report that returns the top-selling products by African countries for the previous month. But they also want to limit the report to only the top 5 countries that sell the most products. The first thing we do is use the chart command to get a count of products sold by country. We use the limit argument to only return the top 5 selling countries. After our search is run, we can see Splunk charted the count data with a y-axis of product name and an x-axis of the country. We now want to get products that sold the most for each vendor. This is not an easy feat since our data is currently in a tabular format. We use the untable command to change the data into a stats-like format. The first argument supplied to the command will be used as the x-axis. We are using the product names in this example. The next argument is the field with the values to use for label names for the data series. We are using the vendor country names. And finally, we tell the command which field holds the data charted series. After running the search, we see that we now have a row for each product name sold by each vendor country and a count representing the games sold, instead of having a chart where the count data intersected at a y-axis of the product name and x-axis of country. This allows us to easily continue to work with the data. We want to get the highest seller for each country. We use the event stats command to create a new field called max that returns the largest count value for each country. Clicking on the vendor country header, we sort results to get a clear picture of what is happening. Notice that we have a count for each game for the country, and a max field that matches the highest number from the count field. We are only looking for product counts that match the max value, so we add a where command. Since there is a good chance that we might have multiple best-selling products per country, we use the stats list function with the product name and count fields to combine them into one result. We now have a report we can share with the team.
The XY series and untable commands function similarly, but perform opposite tasks. The untable command takes a chartable table and converts it into a stats-like output. The XY series command converts statistical results into a tabular format, making them suitable to use in visualizations. We can see within this table on the left-hand side, we have our data organized with the hosts www1 through 3 as the column headers and their values down each column. Once we pipe that table to the untable command, the host values will no longer be the column headers, but they will be stored within a host field. Numeric values will be stored within the field total bytes. Untable is untabling this chart-like table into a stats-like table, whereas the XY series will take the stats-like output and format it into the chart-like output. Now let's take a look at a couple of examples using the XY series command. And let's just start off by talking about single series versus multi-series tables and visualizations that are generated using the stats or chart commands. Now, when we use stats or chart to generate single series data, meaning one or two columns in the table and a single color in the visualization, chart and stats really have no difference. If we go ahead and run this search across our web index, source type of access combined, and get a count of events by host across the last 24 hours, this is going to build out a 2-column table with host in the leftmost column and count in that second column. And if we take a look at our visualization, as let's say a column chart, we will see the leftmost column of host on the x-axis of the visualization and the numerical count values as the magnitude of the y-axis. Now, if I replace this stats command with a chart command, that is going to generate the same single series table and visualization. Now, let's go ahead and transform this over into a multi-series table and visualization. If we revert back to the stats command and get a count of events by host and status, we can see that status is going to be in the second column, host will be the leftmost column, count will be the third column, and we're now looking at, in this case, not the best looking visualization. So what happens here is with this multi-series table and visualization, the stats command doesn't necessarily organize your data in a visualization ready state. Now, if we wanted to, let's say, replace this stats command with the chart command, that is going to format our data differently. We will now all of a sudden see the host values in the leftmost column and the status values as the column headers. If I were to pipe from stats over into the XY series command and follow XY series with hosts, status, and count, XY series will generate the same organization of our data within a table as the chart command does. XY series is reorganizing the data, and we will see that with XY series, I need to specify what column I want on the left-hand side. This will be my host. What are we splitting our columns by, which are our HTTP status codes, and which column from this stats table will end up being the intersection of the cells. So in this case here, once we've built out this table and we specify what goes in the cells at their intersections, which is the count, we can see this table being generated. So essentially, piping to the chart command is the equivalent of using stats and reorganizing that with XY series. We can see here that the stats command followed by a where command followed by XY series is going to reformat that data within the table. Now let's go ahead and take a look at one more example. taking a look here at our basic search across the web data. And we want to compute an overall sum of our bytes, name that bandwidth, and split that by host and status. Now from here, what I'd like to do is I'd like to convert these bytes into megabytes. In order to do that, I need to pipe to the eval command. And what I'll have to do is create an expression for each column in this table, converting my bytes over into megabytes. So for this column here named 200, I will have to set that equal to the value stored within that column divided by 1024 times 1024. From there, these values are going to be converted over into megabytes, and I will have to do the exact same thing for these subsequent columns, resulting in 9 separate eval expressions. Now, that's going to be slightly tedious and not the most efficient way to convert these bytes over into megabytes. So instead, what we could do is replace the chart command with the stats command so that we have all of our bytes stored underneath this bandwidth column. And from here, all we need is one single eval expression that is going to take, let's actually create a brand new field here named megabytes, which will take the value stored within bandwidth, divide that by 1024 times 1024, and let's say we want to round these values to the nearest 2 decimal places. We will wrap this all within the round function and round it to 2 decimals, and we can now remove that bandwidth column because we may no longer need it. And from here, I want to reformat my table so that it's in a visualization ready state. I will follow this with the XY series command. Specify host in the leftmost column, status as the column headers, and megabytes as the numeric values that appear within the intersection of the cells. If I take a look at my table here, I can see this organized in a much more intuitive way. And if we see any empty cells within our table, we can fill those using the fill null command. Now, in addition to the XY series command, we have the untable command. As we just saw, the XY series command takes us from a stats-like output into a chartable tabular output, whereas the untable command takes us from a tabular output into a stats-like output. We have the opportunity to use the chart command along with the untable and XY series command to generate the same result as we would see using the stats command. In some cases, those searches are going to be more efficient than a stats-based search. So let's go ahead and take a look at an example of this. We are going to run a brand new search across our web data. And let's say that we are interested in computing a sum of our price, naming that revenue, splitting that by product name and client IP. Now we'd like to remove this other column. So we will set use other equal to false. And from there, I would like to compute my row totals. I will do that by piping to the add totals command, which will add a column named total that contains the row totals, meaning the total per product. Now from here, I would like to sort on the top 5 selling products. Those are going to be these 5 products listed here with the highest total values. And in this case here, we want to make sure that we're either sorting in ascending or descending order. If I wanted the products with the highest revenue, I would go ahead and sort total in descending order. Now from there, I'm going to reorganize this table by piping to the untable command, specifying product name in the leftmost column. We have client IP followed by count. The client IP addresses are the column headers. And from here, we have the revenue values. So let's go ahead and make sure that we name this revenue and run that search. Now this is organized in a stats-like output. We are then going to follow the untable command with the XY series command and again reformat our data so that now we're looking at the client IPs in the leftmost column and the products in the column headers, reversing what we had before. At this point here, we're going to pipe to the add totals command once again, take a look at the totals per client IP, and then sort on those IP addresses here, the 3 IP addresses with the lowest totals. Now, taking a look at the example here, we can see that we're using chart followed by untable and XY series. This search is much more concise than the search on the right-hand side, using a sequence of stats, event stats, stream stats, XY series. In this case, this search with untable and XY series is going to be more efficient than the search on the right.
The for each command allows us to run subsearch templates for each field in a specified list. Let's start with a simple example to see how it works. In this search, we are getting a count of server errors by the action the user was taking when the error happened, and splitting by the host the error happened on. We are using an eval command to create a new field named total with the value of 0. We want to add up the 3 columns for the hosts and display the results in the total field. We pipe into the for each command and tell Splunk which fields we want to run the subsearch template on. In this example, our template is an eval command that takes the total field and adds its current value with the field we pass to it. We use a token of field wrapped in 2 greater than and less than symbols. This tells Splunk to replace the token with the value of the fields applied to it. When we run the search, Splunk uses the for each command, looping over each host value, adding it to the value of our total field. We can also use wildcards with the supplied fields, allowing us to not need to enter each field name. Earlier in this module, we changed this search to use the XY series command so that we could show the bytes served as megabytes. Let's see how we could also do this using the for each command. The field token can be used anywhere in the subsearch template. Here we are using names of the fields supplied to name the fields created by the eval command. We then use the token to supply the field values to the math that will convert bytes to megabytes. When we run the search, we get the same results we got using the XY series command.
The eval command can be used to modify field values through the use of conversion, text, and conditional functions. Before we learn about these types of functions, let's take a brief look at how the eval command is used. The eval command is a very powerful command that allows us to write the results of an expression to a new or pre-existing field. Once that field is created using the eval command, we can use that field in the subsequent lines of our SPL in the search pipeline. When we create these newer pre-existing fields and write the results of an expression, we can chain all of these expressions together within one single eval command. Now, the eval command has its own set of functions that it supports, just like other commands such as the stats chart time chart command. Difference being, the eval command does not share the same family of functions as the stats command. It will have its own separate, unique set of functions that can be used with it. If we are creating a brand new field using the eval command, that brand new field is going to be added to our result set as we see here on the very right-hand side. We can see we have a table with fields A through D. The current field E does not exist. Once we create that new field using the eval command, that new field will be added to this table with its set of values down this column. Now, if we're writing to a pre-existing field using the eval command, this will modify the actual values of that field as we see here highlighted in red in this E column. The eval command is not overwriting or changing any of the already indexed data. It will only modify the values of these fields at search time. Now, as I mentioned, the eval command supports its own set of functions, and it also supports a set of operators that can be used within the eval expression. The operators that are available are arithmetic operators where we can perform a sum, difference, multiplication, division, the modulo operator, which is the remainder from a division operation. We have two different concatenation operators, a plus and a dot. The plus operator accepts two numbers for addition or two strings for concatenation. And the period concatenation operator will concatenate both strings and numbers. Numbers will be concatenated in their string represented form. Now, Boolean operators are ones that we all may be familiar with, those being an and Boolean operator, or not, and exclusive or. Exclusive or will take two arguments, and it will result in true if they are different, and false if they are the same. And then lastly, we have a set of comparison operators that allow us to compare values to each other and see where we have values greater than, less than, greater than equal to, less than equal to, and even use the like operator if we were interested in working with wildcards. Here we see an example search where we're looking across our retail sales data for all retail events that are coming from the US. We're computing a total price by each state, and we are then creating a brand new field called performance. This field is being set equal to this expression that contains a case function. The case function is a function of the eval command. We are evaluating multiple different conditions that will return to true or false and set the value of performance to see these values here highlighted in green. Performance will take the value of needs immediate evaluation, underperformer, or overperformer. In this search, we have three separate eval commands. Each one of these eval commands is creating a brand new field. The only field that isn't brand new here is this sales field, which was created in the stats command and is now being modified within this last eval command to concatenate a $, which is wrapped in double quotes, being treated as a string, and being concatenated to the value stored in sales converted over to a string with this toString function of the eval command, which is adding commas to these numeric values, resulting in monetary values stored within this sales field. So within these eval commands, string values will be double quoted, we will use a period instead of a plus when we are concatenating strings and numbers. And field values will be treated as case sensitive. When we're working with field names, those will either be unquoted, as we see here highlighted in yellow, or single quoted. Now, there are a few ways to structure our eval commands within our search. I'm going to switch on over into a demo, and we are going to take a look at our network data across the last 24 hours. Searching within the network index source type of Cisco WSA Squid and taking a look at the field sidebar, we can see that we have a few fields, one of those fields being the SC_bytes field. Now with this bytes field, I may be interested in the total bandwidth. So I'm going to pipe to the stats command, compute a total sum of that SC_bytes field. And I would like to view the total bandwidth usage per usage type. I will split by this usage field, and that will generate a brand new table. Now, what I would like to do is convert these bytes over into megabytes, and that's where the eval command comes in. I will pipe to the eval command, create a new field called megabytes, and set that equal to the value stored in this bytes field, and divide that by 1024 times 1024. That will add an additional column called megabytes, which is this new field that I'm creating with the eval command, to my table. And I would like to ideally convert these megabytes and round them to the nearest 2 decimal places. Now, as I mentioned earlier, the eval command supports a set of functions, one of those being a round function. And what I could do is I could pipe to a completely separate eval command, update the values of megabytes, and then round those values stored in megabytes to 2 decimal places. This adds an additional line of SPL to my search. One alternative method would be to maybe, instead of piping to a new eval command, adding a comma with a new expression. So here I'm updating the values in megabytes, rounding them, and if I run this search, that's going to return the exact same table. That is a second way of crafting this search with these 2 different eval expressions. And one additional method is to include it all within the same eval expression. This allows for a bit more efficiency. It doesn't require piping to a completely separate eval command, and it returns the exact same set of results. So there are multiple different ways to write evals. Now, after we create these new fields, or let's say modify any pre-existing fields using the eval command, we can treat those fields just like any other field and use them in subsequent commands within our search. Once the eval command is removed from the search, that field will no longer exist and will no longer be available to be used. So keep that in mind when working with the eval command and creating these new fields. Now, what we'd like to focus on are the various different functions that the eval command supports. There are a wide variety of categories of evaluation functions that we can use. Those range from comparison and conditional functions, statistical, conversion functions, even functions that allow us to reformat our text values within these fields. We'll explore quite a few of these functions in detail, and we can see a few of them listed on this table here. A couple functions that fall under conversion are those such as the toString function and the toNumber function. The toString function allows us to convert an input such as a numeric or Boolean value over to a string. The toNumber function will allow us to convert a value stored within a field or just a standalone value over to a number. Text functions will allow us to modify actual textual values and convert the text into all uppercase, lowercase, maybe replace a portion of text based on a match using a regular expression, or extract a portion of a substring. And then lastly, we have a few comparison and conditional functions that allow us to perform else-if statements, multiple else-if conditions using the case function, or combining values of multiple different fields using the coalesce function. When you run a search, Splunk will try to intelligently represent values as either a string or number, depending on what you are trying to do with them. To use values with arguments that require a different value type, you can use the toString and toNumber functions. Let's start with the toString function. The toString function is a conversion function of the eval command that takes in two arguments. First argument being a numeric field, second argument being one of three options: commas, duration, or hex. If we specify commas as the second argument of the toString function, that will allow us to take the numeric field value that we pass in as the first argument and add commas where necessary. One requirement is for that numeric value to be larger than 3 digits for commas to be applicable. Second option is hex, which will allow us to convert the numeric values of the field passed in as the first argument to hexadecimal. And third option will be duration, where we can convert the numeric value that's passed in into the hours, minutes, second format. Now, as we can see here, we are using the commas option of the toString function. Let's go ahead and take a look at this in a search where we will look at our web server data and look at online purchases that have received an HTTP status code of 503. We are going to go ahead and run a search across our web index, source type of access combined. And if we take a look at our field sidebar, we have a field named action with a value of purchase. We will add that to the search, and we would like to look for values of the status field equal to 503. So we will filter on those events. We can see we have 151 events being returned back to us. And I'm going to create 3 new fields that I'll add to a table using the stats command. I would like to take a look at the total lost revenue due to this 503 status error. I would like to compute the average lost revenue. And I would like to take a look at the overall count. All right. Now from here, we can see that we have a decimal value and we have this total lost revenue, which is a number larger than 3 digits. I'm going to pipe to the eval command, and I'll start with updating this numeric value stored in the total lost revenue field. I will set this equal to the toString function and pass in the field that contains the numeric value as the first argument. And in this case, I'm using the commas option as the second argument, wrapping it in double quotes. Now, if I run this search, I can see a comma being added to this numeric value. I will do the same thing to the average lost revenue field. I can see that I am updating this field's value, setting it equal to the toString function. I'm keeping it within the same eval command, just comma separating. And I am going to pass in the average lost revenue field as the first argument, commas as the second argument. Once I run that search, we will notice that that field is not given a comma, but it is being rounded to the nearest 2 decimal places. For any numeric value that's stored within a field that's passed into the toString function that is not a number larger than 3 digits, that numeric value will be rounded to 2 decimal places if it is a decimal value. We can see the toString commas option behaving in 2 different ways for these 2 numeric field values. Now, one additional way to use the toString function is with the duration option. In this instance, we are using the range function of the stats command, which is acting like a mathematical range. It's returning the difference between the maximum and minimum value of the underscore time field. The underscore time field contains the times stored in epoch time, and it will find the difference and store that in the session time field, splitting this by JSession ID. So what we're looking at in this scenario is we'd like to identify the 5 longest client sessions over the last 4 hours and display those client sessions in the hour, minute, second format instead of just second format, making it a bit more readable for the user and viewers of this table that are looking at where that longest client session came from, what was that JSession ID, and what was that overall duration time. Now let's go ahead and run a brand new search. This time, we are going to work with this JSession ID field. In the stats command, I'm going to use the range function, which is going to take underscore time as an argument, and we will store that in the session time field that we're creating in that as clause, splitting that by JSession ID. Now I can see the total session time being displayed in seconds. That's what these numerical values represent. And I would like to sort session time in descending order. Now I can see this was the longest client session. This is displayed in seconds. I don't necessarily know right off the bat how many hours that is, how many minutes that is. So what I'd like to do is convert that over using the toString function of the eval command. And I could either write to this pre-existing field session time, or I can create a brand new field and I would provide that new field name to the eval command. So let's create a brand new field, and I'll name this field session duration. I'll set it equal to the toString function, which will take these values stored in session time, and those numeric values are going to be converted and displayed in the hour, minute, second format because I'm specifying duration as the second argument in the toString function. Once I run this search, I can now see that the numeric values stored in session duration are being displayed in the hour, minute, second format. And these are actually left aligned within the cells because these are now string types, as opposed to the values stored in session time, which are numeric types. Now, an additional conversion function that we have available is the toNumber function. One thing to keep in mind about the toNumber function is that it is not an inverse of the toString function. The toNumber function is going to take a field or literal string value passed in and an optional second argument, which will be a base. That base can be a numeric value from 2 to 36, default being 10 if no base is specified. Now, if we take a look here at this example, in this search up at the top, we can see that we have a preceding search and then we encounter two eval commands. This first eval command is creating a field called myValue set equal to this string. We would like to convert this string value stored in the myValue field to an actual number, and that's going to be stored in this myValue as integer field. So we'll pass myValue as an argument to the toNumber function, resulting in this numeric value. Now, this second search right below is creating a field called N1, and N1 is set equal to the toNumber function, which is taking this string of 244, and we can see the base is base 8. So we are converting the octal number with base 8 of 244. And 2 is going to take this hexadecimal number, which is base 16, converting it to decimal. The eval command has multiple functions for dealing with text. They allow you to do things like cast strings to upper or lowercase, remove specified characters, or decode URL encoded strings. The upper and lower functions will take a string value and return the string in upper or lowercase respectively. These can come in handy when you need to compare values that might not be normalized in your data. Data cleaning is very handy for modifying and updating your data and preparing it for things like machine learning algorithms or functions that are used within our SPL along with commands. There may be instances where we need to modify the text values that are stored within these various different fields, and we have a set of functions to do that. The upper and lower functions allow us to take these string values and convert them to all uppercase or all lowercase. In this scenario, a user wants to create a new field with the first 3 letters of the category ID, the uppercase product name, and the last 2 digits of the item ID. Let's go ahead and take a look. If we go ahead and run a brand new search across our web index, source type of access combined, we are going to just work with 3 fields. If we take a look here at the sidebar, we have our product name field, category ID field, along with item ID. Now, what I'd like to do is remove any duplicates for these 3 fields. We're removing any duplicate combination of values for these 3 fields. and from here, creating a brand new field with the eval command called lowercase product. If we take a look at the field sidebar, we'll notice that lowercase product does not currently exist. I'm going to set that equal to the lower function, which is going to take the value stored in the product name field. We can see that we have uppercase letters here. With the lower function, I'm going to run this search, and it is going to take all of those product names and place them in all lowercase within this new lowercase product field created by that eval command. I will do the same thing and store that within the uppercase product field using the upper function. And from here, once I have these two different fields with the upper and lowercase product names, I would like to use the substring function. I'm going to create a new field called substring category, and I'm going to pass in category ID as the first argument to the substring function. Taking a look at the category ID field, I would like to extract the first three letters of each category ID. I will pass in the starting position as the second argument, ending position as the third argument. Run this search, and I'll notice in the sidebar, I have the substring category field. Lastly, I will take the item ID field and extract everything from the fifth position onwards. That's going to be the last two digits of each item ID. I will add a comma, specify this new field, use the substring function, pass in item ID as the first argument. If no third argument is specified, it is going to take everything from that second argument, this fifth position, onwards. And from there, I would like to concatenate the values within these newly created fields. The substring category field is going to be concatenated and separated by a dash to that uppercase product field, which will be concatenated and separated by a dash to the substring item field. To see our end result, let's place all of these fields into a table. And what we will end up with here is this end result. We can see where we came from with these all uppercase and lowercase product names. We have our category ID and item ID. We are then concatenating all of these values together. The substring function will allow you to return a selection of a string by supplying index values that tell Splunk which characters to create the substring from. As an example, if we wanted to get the word book returned from this value, we tell Splunk to start the new string after the fifth character and return the next four characters. The third argument is optional. Removing it will return all the characters from the start character on. Negative numbers can also be used with the second argument of substring. We saw an example of the substring function earlier when we talked about the lower and upper function. The substring function is also a text function that allows us to return a substring of the first argument, starting at the second argument, with that third argument being optional. If no third argument is specified, we will take the values from that position specified in the second argument onwards. If this second argument is positive, the substring will start there from the beginning. If it's negative, Splunk will start at Y characters from the end. Now let's take a look at an example. In this scenario, we're being asked to return the employee username from workstations where the names are BG followed by the username. We have 2 digits following BG and that username. Those are values stored within the BCG workstation field. So what we're specifying here is from that 6th position, we are going to take the username, which is the employee, and that's going to be stored within this employee field that we're creating with the eval command. There is no third argument within this substring function because we are taking everything from that 6th position onwards. If you want to replace characters in field values, you can use the replace function. The function takes 3 arguments: the value to run the function on, the characters you want to replace, and the characters to replace them with. Let's take a look at the details of the syntax for the replace function and how many arguments it accepts. We can see the replace function is a function of the eval command. Its results will be stored in a field, newly created or pre-existing field that's specified by that eval command. First argument is going to be a literal string or a field. Second argument will be a regular expression. That regular expression and its pattern will be matched on the values of the field passed in as the first argument. Third argument will be what we would like to replace those matched values with. The replace function is really helpful for masking any sensitive data or information within your data at search time, such as exposed account codes, exposed credit card numbers, which should ideally be masked prior to onboarding the data into Splunk. However, there may be instances where we may need to do this data manipulation and cleaning at search time, and that's where the replace function comes in handy. In this specific scenario, we're looking across our sales entries data, and we'd like to calculate the number of events for each account on the business intelligence server. Notice that the account codes are being exposed, which means we'd like to mask the last 4 digits of each account number. Let's take a look at an example. We'll go ahead and specify index equal to sales, source type equal to sales entries, and I will run this search. From here, notice that I have my account codes being exposed. And if I pipe to the stats command, get a count of events by account code, those account codes are being displayed in this table, and I'd like to replace the last 4 digits. In order to do that, I will pipe to the eval command, and I can write to a new field, or I can just update the values stored within that account code field. Since I don't want those values being exposed, I'm going to update the values stored within that field at search time, and I will set that equal to the replace function. First argument will be that field that contains those exposed account codes, and second argument will be the regular expression. The regex pattern that we will be using to match will be looking at the first 4 digits followed by a dash. And from there, it is going to look at the next 4 digits. And we are going to capture those last 4 digits and replace them with X's. All right, so this third argument here is going to be what we are replacing, what we are matching on with this regular expression. Now let's go ahead and run this search and see what we get back. All of a sudden, we see that our account codes are being masked. Last 4 digits are being replaced with X's using the replace command. Now, if I were to remove this eval command in my search, those account codes will no longer be masked. As long as the eval command exists in my search, those account codes are not being exposed. Here we have a second example where we are showing sales information and we're looking at the client IPs. So we're looking at successful purchases in the online store, looking at our total sales over each client IP by each product, and displaying the 3 best-selling products in the last 24 hours, masking the middle octets of the customer IP address. We're matching on the middle octets using this regular expression, replacing with this third argument. The case function allows us to enter multiple Boolean expressions separated by the argument of what to return if the previous expression evaluates to true. Only the argument for the first expression that evaluates as true will be returned. If none of the expressions return true, an empty value is returned. Let's take a look at an example of the case function. The case function allows us to do data normalization, where we can evaluate multiple conditions and take the value based on whether those conditions evaluate to true or false. In this search, we're searching across 2 different source types, and we are computing the total revenue, getting a count of the radio frequency ID numbers, storing that in a field named staff count, and splitting that by this location field. Now we'll notice in our results that the location field is not exactly consistent and normalized. We can see that we have various different ways to specify these locations with not necessarily a consistent naming convention. Now, what we would like to do as an alternative is use the case function of the eval command to normalize our data. With this eval command, we are creating a new field called the location field. We're essentially overriding the contents of the location field, not necessarily making it a brand new field, but taking the pre-existing field and providing it new values. If the location field within an event is equal to BOS or Boston, location will take the value of Boston. If it has a value of LDN or London, it will take the value of London, and same thing for San Francisco. This will standardize the location values to these 3 specific places, and we can then see the total revenue along with the staff count for each one. Now from here, notice that we are normalizing the location field before transforming the data. Whereas in our previous search, we were using the stats command before the eval command. Normalizing after transformation and calculation of statistics won't necessarily generate our expected desired results because we are transforming these fields within the stats command and grouping by location. So before we even use that location field, we'd like to normalize its values first. which is why we are preceding the stats command with the eval command. We can now see that the values of that field are being normalized to these 3 different values of Boston, London, and San Francisco. One thing to keep in mind about the case function is if none of the cases, meaning none of the Boolean expressions, return to true, then this field will essentially take a value of null. So if we would like to have a condition that always returns true, then the very final clause will be something like 1 equals 1, or in this case, the true function, which always returns to true, so we will take the value of location. The coalesce function will take a list of arguments and return the first value that is not null. On the topic of normalizing field values in your data, the coalesce function is an additional function of the eval command that allows us to normalize fields from the results set, where we have maybe 2 or more field names that represent the same data. The coalesce function takes multiple arguments, those being the fields whose values we'd like to normalize, and store within this newly created field. This will return the first non-null value provided from the field list. Now we can see here in this example, we would like to normalize IPs from the online sales and web security appliance data servers over the last 5 minutes. We have this search looking across our Cisco Web Appliance data and our Access Combined data. The Cisco Web Appliance data contains client IPs that are stored within the CIP field, and the Access Combined data contains IP addresses stored within the client IP field. We are going to coalesce the two and combine the values stored within those 2 fields into one single field called one IP. And we can see in our table that the one IP field is a combination of both CIP and client IP. We can see under the source type column which particular source type that IP address came from, but we're now normalizing and containing all of those IP addresses within one single field called the one IP field. Hello, welcome to Leveraging Lookups and Subsearches. I'm Jessica with SPLUNK Education. In this module, you'll learn how to use lookup commands, correlate events with subsearches, and use the return command in a search. You may already be familiar with lookups, but let's look at a quick overview of how they work. Lookups allow you to add other fields and values to your events not included in your index data. We can combine fields from sources external to the index with searched events based on paired fields present in the events. This might include CSV files, scripts, or geospatial data. Some examples would be tying a user's personal information to their RFID or text descriptions for product IDs, data that would be useful for search but might not be available in your index. After a lookup is configured, you can use its fields in search and it shows up in the field sidebar. By default, there are 4 types of lookups. File-based lookups populate your events with fields pulled from CSV files. External lookups append data to your events through the use of Python scripts or binary executables. KV-store lookups access key-value pairs from a KV-store collection, and geospatial lookups add geographic information to your events by referencing a KMZ or KML file. Let's take a look at some commands that can be used to interact with lookups in searches. Lookups are a way to add additional fields to our search results at search time. As we can see in this example, we are looking at some badge reader data, and if we expand an event, we can see the fields associated with that specific event. There is an RFID number, which stands for radio frequency ID number, that is associated with an address, address description, but we don't necessarily have any information about who the user, first name, last name, email, and department information is. So in that case, we are going to leverage a lookup by bringing in the set of fields that are associated with each specific RFID value and look at the associated user with the details of that user. The input lookup command can be useful for searching and validating the contents of a lookup table. The input lookup command is a generating command, which means that it is going to be the first command in our search, and it will not be preceded by a search. We will follow the input lookup command with the name of the file or the lookup definition that we would like to examine and validate. In an example here, we are passing in the lookup table file to the input lookup command to verify whether the contents of this products.csv file were loaded in properly. This will display the set of column names and the values down each column that exist within that CSV. If you need to invoke field value lookups in a search, you can use the lookup command. The lookup command is the command that we use to populate the fields being brought into our search results at search time from our external lookup file. This lookup command is preceded by a search, and it is going to be followed by the name of the lookup definition and the set of fields that we would like to output to our search results. By default, Splunk is going to add all of the remaining fields in the lookup table to the events. We can be explicit about what set of fields we would like to output by following this output clause with the set of lookup fields. Output will overwrite any existing fields. Output new will not overwrite existing fields. These fields will only be available in our search results for as long as this lookup command exists within our search. Once we remove the lookup command from our search, those fields will no longer be available via the search results and via the field sidebar. Now, there may be instances where we may want to automate these search results, and that would be the process of creating an automatic lookup instead of piping to the lookup command every single time we want to work with these set of fields. This search here invokes product.csv, and it uses product ID as the input field. The set of fields that are output are going to be price, product ID, product name, and sale price. An alternative to having to pipe to the lookup command every single time would be to create an automatic lookup. Here we see an example of searching across our web server data, source type of access combined. We're looking for all successful purchases in the online store, and we are going to invoke this products.csv lookup. The input field is product ID. We will output price and product name. And price and product name will now be available as fields in the sidebar as long as this lookup command exists. We can then treat those fields like any other field, compute a sum of our price, name that sales, and split by product name. This is an example of passing in the lookup table file name to the lookup command. An alternative example is passing in a lookup definition to the lookup command. This lookup definition is called holiday_product_promo. Input field is product ID. Output is sale price and product name. Those fields will then be made available, and we can then compute a sum of our sale price, name that sales, and split by product name, displaying this table. So this is an example of a scenario in which your knowledge manager may have just uploaded a new lookup definition for the promotional holiday products, and we've been asked to calculate the sales for each product in the last 24 hours using the promotional sale price. Now we can limit the set of distinct values with lookup. An option here would be to use the same name for the lookup field and the lookup destination field, which will limit the number of distinct values for the lookup destination field. In this case, the input field is user, the output field is user, and we're just going to limit that to a value of 6. If we take a look at an example and jump on over into a demo, what we'll see here in a lookup table file under Settings Lookups, selecting Lookup Table Files and adding a new CSV, we're going to select known users.csv here. We'll go ahead and give this file a name, save that, and from there, select the owner as myself, verify that that CSV file was loaded in properly, and then create a new lookup definition. If I select file base as the lookup type, known users.csv as the lookup table files, and I give this a lookup definition of known users, I'll go ahead and save that. Jumping on over into my search, I will invoke this lookup, and really before I do that, just verify that it was loaded in properly by piping to the input lookup command, specifying known users.csv, which is the lookup table file, and I'll verify that that is a CSV file that contains a user column with a list of all of those users. And I, from there, may be interested in running a brand new search, invoking this lookup across my security index, source type of Linux secure, across the last 24 hours. We'll take a look at our events, and we are going to filter on the set of known users. Currently, we'll see that we have 100 values for this user field. But once we invoke the lookup here, by piping on over into the lookup command, specifying known users.csv, user will be the input, output will be user, renaming that as new user, because we are going to filter on only those set of known users. So we'll go ahead and run that search, and we'll notice in the field sidebar that we have the original user field. However, we have a new user field that's only filtering on those set of known users in our events coming from that CSV. To write the results of a search to a lookup, you can use the output lookup command. The output lookup command is preceded by a search. That search's results are going to be written to the specified file name or lookup definition that is specified in the output lookup command. We can see an example here of the output lookup command writing those search results to a CSV file named users.csv or to a lookup definition table name of user group. That lookup will be created in the app that we are currently running that search in by default. Otherwise, if we set create an app equal to false, which is an option that's built into the output lookup command, that is going to save that lookup file within the system lookups directory. One example of using the output lookup command is running a search that is saved as an alert, where we are using it to create a searchable lookup. In this example, we're searching across our failed Linux secure events across the last 30 days. We're going to get a count of events by user and compute the daily average by dividing the count by 30 and rounding it to the nearest integer level. And from there, writing those results over to this CSV file called averages.csv, which is going to be created in the application that we're currently working in. From there, we can save this as a report or an alert, run it on a schedule, and that averages.csv file will be updated frequently, and we can then use the input lookup command to verify the contents of it.
A subsearch is a search that passes its results to an outer search as search terms. They can be used to narrow down the set of events you are searching on, or used with commands to combine results of one search to the results of another. Subsearches are enclosed in square brackets and must start with generating commands, like the search command or tstats. Subsearches are always executed first before passing the results to the outer search.
In this example here, we can see we have our basic search, followed by a subsearch in square brackets, followed by a set of additional commands. The results of the subsearch will have an or Boolean placed between them, and we will see that search expand into anding the results of that subsearch with those field value pairs separated by or Boolean operators. Now, we loaded in that known users.csv file earlier. We're going to use that known users.csv file within an input lookup command in a subsearch to access that lookup data and pass values to the outer search. In this example, let's go ahead and jump on over into running this search and taking a look at our security index. Source type of Linux secure. We're looking for failures, and we want to see the unknown users. We know that we've loaded in the known users from that known users.csv file. And so if we wanted to filter on the unknown users, well, what happens by default with a subsearch is we are going to and the results of that subsearch here. In this case, looking for all of the security events that contain failures and users coming from this known users.csv. If we'd like to exclude those users and only return the unknown users, we'll place a not Boolean in front of that input lookup command, run this search, and what we'll do from there is display this information within a table. Using the stats command, we will look at the unique values of the IP address, name that attacker IP. We'd like to get a count of events as failures, split by user, and we'd like to see which users had more than 3 failures. From here, we want to make sure that we sort those failures in descending order. And so we can see that the administrator user had the most failures. These were all of the attacker IPs that that specific user used. So in this example here, we are including a not operator before our subsearch to exclude these lookup values. And if we take a look at the search job inspector, that search job inspector will display the expanded search string. Heading on into inspect job, scrolling on down into the search job properties, what we will see here is a not Boolean operator placed in front of each field value pair coming from that known users.csv, invoked by that input lookup command within the subsearch in square brackets. In this particular search, this search is going to count the number of failures by source IP. It will return a lot of results. So we'd like to go ahead and improve this search and the results of this search, making them a bit more meaningful and filtering on those particular failed logins not coming from internal IPs. So we will exclude any IP addresses that begin with 10, get a count of events by source IP, and look at where the count is greater than 10. So look at where we have more than 10 failed login attempts. But it may still be unclear in terms of which of these IP addresses ended up successfully accessing the network. So what exactly are we trying to find? An external IP address with multiple failed attempts and one or more successful attempts to access the network with a valid password. So in this case, we'd like to use a subsearch to find these specific IP addresses that have received multiple failed events and send those to the outer search to see which ones were able to access the network. So we will build out a subsearch to do this. Let's go ahead and run an outer search and inner search separately and see what events we get returned. Running a search across index equal to security, source type of Linux secure, I would like to see the IP addresses that were accepted and were able to log in successfully across the last 24 hours. Now I can place those IP addresses on a table. However, I also want to see which of those failed to log in more than 10 times and were eventually accepted into the network. So in that case, that's going to require searching across failed passwords, excluding the internal IP addresses, and getting a count of events by source IP, where the count is greater than 10. And we can see this table here displaying those IP addresses that failed to log in with a count greater than 10. Now, of these IP addresses, which ones were eventually accepted into the network? Well, that would require passing these list of IP addresses to an outer search that will filter on Linux secure events that contain that term accepted in them. So what we'll do is we'll wrap this specific search as our subsearch. The subsearch needs to begin with a command, so this will begin with a search command. And we will precede this with index equal to security, source type of Linux secure, accepted, and from there, if we run our search, we'll notice that we're not getting any events being returned. If we look up into the job inspector here and try and diagnose why that is, in the search job properties, we'll notice that we are returning a count and a source IP in that subsearch, where we're only really interested in returning an IP address to filter on those IPs that were eventually accepted into the network. So we need to be restrictive within the subsearch on what field we are returning to the outer search, and we will do that using the fields command, passing that source IP field. From there, we will see 314 events being returned, and we want to place those IP addresses onto a table. So I will first remove any duplicates, and from there, pipe on over into the table command, listing out those unique IP addresses. Now, if we'd like to run the inner subsearch separately and take a look at how Splunk will format the results of that inner search, there is a format command that allows us to do this. I can go ahead and remove the outer search, run the inner subsearch, and we'll notice that we have two fields returned in our table. If I pipe this to the format command, the way that these results will be formatted will be as field value pairs with count and source IP, with OR Boolean operators placed between them. Which is why using the fields command and only passing that source IP field to the outer search is going to format those IP addresses with OR Booleans placed between them, and those will be used as filters for the outer search.
Subsearches are useful, but they have their limits. Multiple subsearches can be used in a search, and subsearches can be nested. But be careful, each subsearch requires an additional search on your deployment, which could quickly eat up memory and CPU. They have a default time limit of 60 seconds to execute, after which they are finalized. Once that time limit is reached, only the events found during those 60 seconds are returned to the outer search, whether the search is complete or not. Subsearches also have a results limit. By default, they only return up to 10,000 results. Once it's met, search stops, resulting in a partial set of events. The limit can be adjusted, but only by a Splunk administrator. Because of these limitations, we should focus our subsearch on a narrow set of data. Ideally, a subsearch produces a small set of results, filtering out unnecessary events. It then returns that narrow set of results for the outer search to work with. If an outer search is set to execute in real time, then its subsearch will execute over all time by default. In order to avoid exceeding the subsearch's time limit, we can include earliest and latest time modifiers in our subsearch. Subsearches are slow. After all, there are 2 searches instead of 1. If you can use a combination of stats and eval in a single search instead, they typically perform better. A rule of thumb should always be to only use a subsearch when there is no other way to retrieve the data you need.
Now let's take a look at an additional example here. Let's say a tailgater likely followed someone into the building, and the CSO wants a list of tailgaters during the last 4 hours. We would like to build out a subsearch to find the specific users that badged into the building, and create an outer search to find users that logged into the network but did not appear in the subsearch results. Using a subsearch here, we are placing a not Boolean operator in front of that subsearch, which is searching across our badge reader data for any events that contain an event description of access, and returning the unique set of users to the outer search, which is filtering on the Win Authentication security events that contain an event code of 540 or 4624. This will return the unique set of users that badged into the building and logged onto the network, displaying those users in our table. One alternative to using a subsearch is the eval or stats command. If you are working with a very large set of data, eval and stats will perform a lot better than a subsearch. We can see by inspecting the job inspector here, this search ran in 0.392 seconds. This completed 30% faster than using a subsearch. On the network with many users, the search using a subsearch could run for a very long time. If it's run pretty frequently, it could be resource intensive. And so the eval command in this example creates a new field called badge access, which assigns a value to each event in the history access source type of 1 or 0. The stats command creates a new table where each user is listed with their badged in value. And we are limiting the results to users with a badged in value of 0, meaning that they did not appear in the history access source type. We will see that this search with eval and stats is going to perform better than the search with the subsearch. Now, in terms of troubleshooting our subsearches, we want to make sure that the subsearch is wrapped in square brackets. It begins with a command. And along with that, we are returning the field that we'd like to filter on in the outer search. One recommendation is to run the inner and outer search independently, verifying that they both return results. Take a look at the job inspector, examine the runtime of your search, and determine whether that search can be formatted or built using the eval and stats command for better performance. The return command is used to pass values from a subsearch to the outer search. In most cases, using the return command at the end of a subsearch removes the need for the fields command, a rename command, format, dedupe, or head command. The return command is preceded by a search and followed by a count value, which is considered an integer, which will specify and tell Splunk how many rows of results to return. By default, it will only return the first row. And from there, we can provide one or more fields to return separated by spaces. We have the option to just return the values of the field or provide a new alias to rename the field. Let's take a look at a couple examples. In this first search, we are returning source IP, which will by default return the first field value pair with the source IP field and its value. If we place a $sign in front of that source IP field, it will only return that IP address value and exclude the field name from being displayed in the results. And if we provide an alias in front of the equal sign, followed by the name of the field that we're working with, in this case, source IP, this will rename source IP to that alias field name of IP. Typically, this is done if the outer search results has a field name differently than the field name in the inner search results. In this case, the field may be named IP, and we can quickly rename it using the return command. If we're comparing return to the fields command, we can see here that the fields command will display and return all of the field value pairs of source IP. If we want a little bit more control in terms of how many results are sent to the outer search, in this case, let's say first 3 results, we can include the return command with a limit of 3 followed by source IP. Now heading on over into an example here, if we take a look at a search that we ran earlier with the fields command, we can see that these are the field value pairs that are returned. But if we switch this on over to the return command, we will see that first IP address being returned as the value of source IP. If I place a $sign in front of that source IP field, it will only return the value, and I can go ahead and create an alias as well. Setting a limit here will return the first 5 IP addresses separated by an OR Boolean. In this case, allowing us to be a little more restrictive in terms of how many values are passed into that outer search.